Lace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with fire walls splinter to confetti bits. I'm curating leaves at the after party, sipping tearless tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constant.
Hey, hey.
Okay.
All right.
Yeah, I can, so I can move it like throughout or no? Okay. So like if I start here.
That's not a problem. But the one thing I'm going to ask you, don't go gangster on me. Don't do any of this nonsense.
Gotcha.
Just keep it like that, because if you talk like this, no one will hear you.
Gotcha.
Okay? And then, and put it back when you're done.
Okay.
All right?
Cool.
So that's it. But we're not starting for, geez, what do we have?
Like it's
We got like
9
10
minutes.
10
Yeah.
minutes.
No, yeah.
So yeah, if you want to hang out down there or whatever.
Cows are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we pity let this city on force and chains. We pity let this city with regen brains. We pity let this city on force and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas on She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with a do with a do with do with do with do to do do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of just next bottleneck. I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes smoked and truce from dress sheets. That's nullifier sniffing by my clothes too crisp. Mainnet gossips tastier than chips. Story, furry, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dance scene. Head it up to the entropy. Lace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with as firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it guitar slide. Guitar slide. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. flutter like drunk bumblebees. Maximize the orphans. They cackle and shout. Self-sustaining hugs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin. Dug in tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso stream through my cortex.
Day of ETH Denver. We are here with the Biddler stage, and I will be the MC for today. And the first speaker we have today is Austin Jeter, from Head of Ecosystems and Growth. Please come to the stage and give a little bit about yourself. So,
Thank you so much for the intro, Chris. Appreciate it. As Chris said, my name is Austin. I'm the head of ecosystem growth here at UDU, and I'm super excited to share how we're tackling some challenges in the DePIN space. Just as a quick overview about UDU, our vision and mission is to revolutionize how we interact with physical resources to create a future powered by a seamlessly interconnected and infinitely scalable peer-to-peer network. And ultimately, we want to create cutting-edge infrastructure solutions that unlock the potential of DePIN applications, driving the future of decentralized resource sharing. So about DePIN, if you look at DePIN from a 10-year growth horizon, we're still in the very early innings. It is expected to grow anywhere from 100 to 1,000 times over the next decade. Right now, we see a market size of around $1 billion in a wide array of sub-verticals, and these include wireless, energy, compute, and more. And when you think about DePIN as well, revenues have actually 100x'd from 2022 to 2024. So this is definitely a great space to be in when we think about utility. So DePIN has a bevy of challenges, one being the tech stack. Because of the hardware element, DePIN projects take a little longer to build and to code. The launch velocity of DePIN projects, generally on the quicker end, can take anywhere from like a year to 15 months. Additionally, as any Web3 project struggles with, they're looking to drive consumers and customers to their individual project, and so demand is very hard to come by. Additionally, there's issues with liquidity, and one of the challenges that we're going to jump into next is actually the sharing of resources on the network. So the first challenge that we're going to tackle today is actually the fragmentation of the DePIN market, which limits hardware efficiency, reduces user returns, and that's due to a lack of a system for effective resource sharing. And so with that in mind, the current user flow for DePIN projects is users need to install and actually operate different client apps, which leads to a complicated management of all the DePINs that you're contributing your resources to. And thus, that makes user adoption very challenging, which could potentially stall industry growth. So our approach to this is just as a quick background, UTU is a L1, and so with that, we're able to provide consensus and security layers. And on top of that, we're building a DPIN client hub, which will enable you to contribute resources to a bevy of projects in a centralized, all-in-one user interface. And so with that, we vertically integrated a solution to enable users to share their compute that not only benefits the resource shares, but also the protocols that onboard with us as well. Additionally, we have a subnet on our L1 that is specifically designed for the DPIN space. With that in mind, you can see that all roads lead back to the subnet when it comes to consumers, app builders, our community, as well as our infrastructure and protocol builders as well. We're able to support these stakeholders in a wide variety of ways by the community sharing their resources. Builders are able to deploy easier, and consumers are ultimately able to benefit by receiving incentives for their hard work. So just as a quick overview of our architecture, you can see that applications are able to build developers are able to build multiple different kinds of applications on our chain. We're not only exclusive to DPIN, even though that's our primary focus, but builders can build other Web3 dApps as well in Web 2. Additionally, as mentioned earlier with our client hub, these builders can leverage our resource marketplace where they can buy, compute, GPU, a range of other services like internet bandwidth as well. And all that is enabled by the DPIN subnet as well as the foundation, which is our L1. So thus far, we have a few projects within our ecosystem, specifically DPIN. The most notable couple are U2 DPN, which is a management companion for DPN node infrastructure. Just to highlight a couple stats, we have 87,000 contributor nodes, 77 million total sessions, which have led to over 90,000 gigabytes of total bandwidth that's been distributed really just from users accessing this app from their phone. Additionally, we have Hermes, which is also a leading DPIN infrastructure for real-time chat and streaming. You'll see this being very useful in more of your SocialFi applications, as well as your GameFi applications as well. And so with Aramis, we've actually been able to reduce cost by 26 times compared to competitors. And also the latency is 5 times faster than the competitors as well. And additionally, upcoming, we have our Zenith EPN, which is secure private internet that's also very fast. That's also going to be built on top of the U2 DPN as well. Now, this isn't all. We want to support DPIN projects in a wide variety of ways. As mentioned earlier, we're hoping that we can help them accelerate their time to market, enable them to drive rapid value capture, and provide them with marketing support. Something major to highlight is actually we're the founders of the DPIN Alliance, which we've built or created with our investors JDI as well as Chain Capital, and thus far this community has over 1 million users to support DPIN. Initially, the first part of this collaboration was to lead to a experience on Telegram, which has led to 270,000 DPIN Alliance app users. And from the B2B perspective, we're hoping that projects within the DPIN Alliance are able to forge partnerships to help and drive scale their projects as well. Let's see, that looks like the same. Cool. So outside of that as well, deep in projects, they need a lot of support in a bevy of areas. We've kind of touched on a couple of them already, but one that we haven't touched on is capital. We want to be able to support them in infrastructure, hardware, platform, and driving consumers to them as well. Additionally, we really just want to be a partner that is with these deep in projects from start to finish. And so you see some of the comprehensive support areas below that we contribute to deep in projects. Thus far, even though UTU is still pretty new, we have a DeepIn community and around 37 projects that have onboarded with us thus far. We mentioned U2 DPN as well already, but the areas of DeepIn in which we add value and where builders are onboarding onto our chain expand beyond the DPN space. We see Lingo AI with on the AI side. We have Aramis on telecommunication, as mentioned earlier, mobility, et cetera. So again, we really want to be that all-in-one partner to these DeepIn projects. Furthermore, here's a look at some of our traction thus far. We have 1 million users across the network, 900K monthly active users, and over 2 million total transactions. We have a ton of social media traction as well, KOLs that can support projects within the protocol, and media partners as well to provide support and project our ecosystem. Additionally, we have a bunch of partners that we're working with as well. One I want to highlight is Masari. They've actually done a report on us, so you can check that out on their website. But we also are very focused on either sponsoring or hosting events for developers. We've actually are very proud to have a $25,000 bounty for this week's Build Week at ETH Denver in the areas of RWA, DeepIn, SocialFi, as well as NFTs. And so we're excited to continue that traction and supporting developers and hopefully onboarding some really great founders. Furthermore, touching on the capital point, we are able to provide capital via grants, but also we have VCs within our network who we can, make intros or who can also support these early stage companies in their investment journey. As mentioned earlier, we do hackathons and we try to again put our ecosystem in the best position to be successful. This is a fun slide because we actually have a phone that's coming out as well called the U phone. And so ultimately the goal there is again to help reduce that fragmentation of resources. We're spearheading this with JDI Ventures, who's also an investor in Helium, Demo, Geodet, and some others. So some other top DeepIn projects, and they're very focused on manufacturing hardware. Also, we have quite a swell team, good team from early stage contributors to ETH, multiple time founders as well that's working in one direction on DeepIn as well. And to conclude the presentation, please feel free to find us at booth 507 at ETH Denver. If there's any questions about grants and that kind of thing, I'm happy to be as supportive as possible. Thank you.
Okay, thank you so much, Austin. I just have a couple questions. Thank you so much for your talk today. If I wanted to build on your stuff, what would be, if I had friends to work on your stuff, who would your target audience be for your application?
Yeah, so we're in the process of onboarding some really great builders onto our chain, as you mentioned. As far as what type of projects might we be most interested in, it really varies. Like, we're very focused on AI, we're focused on IoT, all that other it's very flexible on that end. We're also looking forward to really driving some real-world utility as well and enabling businesses to share their resources as well.
Okay, amazing. Thank you so much.
Thank you so much as well. Happy to be here.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Blood eyes everywhere, not just 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dance scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. bugs flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging notes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Old as speak, young as each block mine down. Professor Way's got the future on spin, urging notes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains.
Hi, welcome back to the Biddle stage, and today we have our second speaker. His name is Salman Vestemir from Chain Opera AI, the co-founder.
All right. Hi, everybody. I'm Salman Vestemir, co-founder of Chain Opera, and I want to tell you a bit about what we are doing and what we enable at Chain Opera AI. All right, so as we all know, AI is booming, right? It's promising us a $1 trillion economy of agent and app builders that are building exciting applications, exciting agents on top of many resources, such as data, GPU, and models that are being built every day. What's next? There is a lot of excitement around AI agents, both in the Web 2 space and Web 3 space. The reason is that agents, not only they are powerful AI models, but they can also do powerful actions on our behalf. They can automate things, they can enable many things that are maybe very difficult for us to do. That's why you see in Web 2, it is predicted that that's going to be the next wave of AI. And in Web 3, also we see a lot of early excitement from both traders and agent builders. But what are the challenges? So at Chain Opera, we are seeing 4 main challenges that we are seeing in the Web3 AI agent space. The first one is that maybe the current AI agents are driven by hype, not the utility. Right? So it's kind of a meme frenzy. It's like, they're exciting, you get maybe excited about them, but there is not a specific or very strong utility that enable. That's not good for a long-term impact. We see that maybe there are various launch pads for creating and launching agents, but they don't give us capabilities to build utility-driven, powerful agents. These agents, they are not truly decentralized. They have a token, you can buy their token, etc., but they are not running on a decentralized resources. You cannot be part of their economy by contributing data, contributing compute, and be a co-creator in such agents. And related to that is they are a bit non-inclusive, right? And you don't get the data ownership as you contribute to the agents. That's why our broad mission at Chain Opera is to bring in 3 things to the world of decentralized AI agents. Co-ownership, so we can all co-own exciting, powerful AI agents. Co-creation, that's where we can all, AI developers, AI agent creators, resource providers can collaborate to build powerful agents, and agents that are built for humanity, they have utility. This is backed by a technology we have been building for several years, that is our federated AI operating system and platform. So with that maybe high-level introduction, let me tell you what is Chain Opera. So Chain Opera, maybe at a high level, you can think about it as 3 layers of technology stack. Federated AI operating system is where any AI agent builder can come, get the tooling, get the capabilities that they need to launch Web3 AI agents that everybody can be part of their economy. These Web3 AI agents, they will be manifested in our mobile app, AI terminal, that lets those agents to have utility, everybody using them in their daily life. You can contribute to them by providing data, feedback to the agents, so we collectively make them better. These agents would be running through our federated AI platform across decentralized resources. These would be decentralized GPU providers, for example, various deepin projects, decentralized model providers, both Web3, Web2, as well as data contributors who want to empower the next wave of AI. The blockchain and protocol is connecting this entire ecosystem, which is multifaceted and has various flows of the value in the system. So now if we look at more maybe the details of the product, so as a builder, you familiarize yourself with that, there are the 3 components of the Chain Opera AI. Federated AI OS and platform, as I mentioned, that's the scenario that we enable creation of the agents that are running across decentralized GPU, decentralized data, decentralized model, and decentralized trust, right? So it's bringing co-ownership across many contributors to the agents. It also has a launchpad that brings the co-creation. So AI developers can bring in their creation, they can bring in their frameworks, various exciting agentic frameworks to let people creating powerful AI agents. The second component is the AI terminal mobile app That's where these agents will not just be sitting on a cloud somewhere on a web page, right? They will come to your phone, so you can interact with them on your daily life, anywhere you wish, across any applications. So it makes the agent interaction very easy. It enables human contribution, right? Bring humanity to the AI, and also empowering people to get rewarded as we make AI better. And finally, these agents, they have their own economy, so everybody can be part of their economy if they are interested about them. Now let's get into maybe how does it look like? What is the demonstration of this one? Let's just start with a mobile app. That's the scenario that everybody, like it's a B2C app, everybody can interact with these agents in this ecosystem. So it's kind of, you can think about it as a gateway to community-built agents that are either built in our community or other communities. It also provides a keyboard. Think about similar to Apple Intelligence, that the interface is through a keyboard that you can use anywhere on your phone to contribute to the agents. So let me show you how it looks like so you can feel it. All right, this app, the mobile app, that's where you can see the interface of the app, right? We have just released for the test group. Right? At the bottom, you can see there are various components. AI Terminal is the gateway that you can interact with many agents. For example, here, I have enabled a variety of agents that are built in our community and can be used through AI Terminal. And then Discover is going to be the place where you can discover these agents. For example, you see maybe there is a deep search that can do a lot of studies for you. So if you are interested, you will add that to your skills. But then there are many other type of agents. For example, Web 2 agents, as well as Web 3 agents that can do a lot of the crypto activities for you. For example, they can do crypto studies, market studies, they can come up with a trading, automated trading, etc. So any of these is kind of, you explore them and you add them to your skill set, right? That's what we call that. Now, how would you use them? So let's say, for example, sentiment analysis, I want to use them. As I mentioned, the way that you will use them is through the terminal. Think about it as a super agent that is gateway to all the skills you want to use. Now you have two choices. Either pick each agent directly, use that, or let the auto mode think about what are the best collection of agents that can solve your problem, right? So let's look at some examples. For example, here we have an extremely fast agent that can do inference very fast. Maybe I want to try that. Okay, so I give it a command, introduce Chain Opera AI. You see, before even I finished enter, it has generated the full content for me, so it's very fast. Maybe another one, deep search, right? This can do deep studies for us. I say, maybe why did Bitcoin price fell earlier this week, right? Do your studies, give me insights. Now this agent creates a research plan. How would I study this problem? What are the resources I want to look into? And come up with an action item that generates insight on my behalf, right? So you give it a bit of time, goes through all of this research progress, and at the end it finds 26 leads, 18 references, and generate a comprehensive document for me. And as I mentioned, you don't need to use them one by one. That's where the auto mode will come, and I think that's the power. We want this terminal to get more powerful as you add more and more agents, right? Having 1,000 separate agents doesn't make you 1,000 times more stronger. But through this collaborative way that you add agents, you can make this super agent 1,000 times more stronger. All right, so here is, for example, a scenario where I used it in the auto mode. All right, now let's move to other part. For example, we have a market. That's where you can access various crypto markets where the agents maybe want to read about them. They want to, get market insights about them and do actions there, right? So that's where a partnership with a variety of market builders, dApps, etc., that we can add to the ecosystem. All right, and finally, there is the me component of the app. That's where, as a user, you can get rewarded as you are contributing to making AI better. And there are various modes of contribution. the strongest mode through what I call the AI keyboard. AI keyboard is the interface where you start giving input to agents, where you give feedback on the result. And that's how humanity comes into play. So let's see how we can use the AI keyboard. All right. So the beauty of AI keyboard is you don't need to use it within the app. You can use it within any other app on your phone. For example, here, let's say I go to my mail app and I want to draft an email to a potential collaborator, right? Inside this email, maybe I want to start by saying, introduce Chain Opera AI, but I don't want to write it myself. I want to call a collection of agents in our community to solve that problem for you. No problem. What I can do, let me show you a bit slower here. All right, so what I can do is enable Chain Opera AI as an operating system layer keyboard, right? That can be interacted the same way as any other keyboard. You can interact through that. Now when I do that, now you can see Chain Opera becomes available in your app. And then you can call your favorite agents, right, to solve the problem. Maybe in this case, I will use the Ask AI to solve my problem. So I will pass it to Ask AI. It will do its studies, right, create a brief introduction. If I'm happy with that, I will include it in my email and send it, right? So it's the utility-driven agent creation. I can also use it for more fun things. For example, creating a meme, and alongside of my message, sending it to my collaborator. All right. So let me come back to the presentation. Hopefully this part gives you a highlight of what we mean by bringing utility to the agents. These are the agents, you can use it anywhere in your daily life. How we bring in humanity to the AI by contributing to the agents. But let's say you get excited, you want to build agents in our community. What can you do? That's where our federated AI platform will come to play as a way to enable people to create powerful agents that become available in the mobile app used by many users. What will be the component of this platform? First of all, as a creator, I can come and access a variety of models and agent frameworks that are built by community, maybe by AI community, right? Because I don't want to know what are the powerful frameworks. Maybe I just want to customize it and give it the right tooling. Then we give you AI agent creation studio, which is a zero code so that you can just pick the framework, pick the model, and launch your agent. And then GPU and data contributors can join this ecosystem to contribute resources that are needed for running the agents on the cloud. So now you can see here, for example, this is one framework. In this framework, there are various knowledge contributors. Maybe they contributed the data that is needed for the agents to give them a context. There are various GPU contributors and trust contributors, right? That's also become very important. Who is backing these agents that you want to launch? So now what you can do, use those frameworks, create your agent, and then the agent will be placed as a skill in the mobile app that I showed you. So everybody can use it, right? Very friction way to get your creation to the hands of millions of people. Now the third component of this, behind the capability to launch, create, and use the agents, would be the blockchain and protocol design. And the goal of that is to think about these multifaceted, right, a stream of value flow from end users, agent creators, to resource providers, either compute, data, model, or annotation, right? The role of our layer one blockchain is to connect all of them together so they can collaborate together and create this ecosystem. Right? So you can think about this. Maybe OpenAI is an example of a Web2 ecosystem that creates an ecosystem for everybody to build and launch agents. Here is a layer one Web3 ecosystem that you can join and launch and build agents. So what is special about that? So the reason you will need to do it is that, first of all, this layer one is driven by what we call a proof of intelligence. There are many ways to contribute to AI. compute, data, interaction, usage. Proof of intelligence will keep track of how different parties are contributing and make sure everybody is getting rewarded proportionally. Another part of it is AI is a very heavy computation task, right? So we want to incentivize nodes and participants who can do very fast AI inference and training to join this ecosystem. Now, this would be like, I think, gives you a very good view of different facets of the product that we have been building. All of this has been based on years of research that we have been doing along decentralized machine learning, blockchain systems, security and privacy, to make sure that you can create such a product that is as strong in AI, as strong in blockchain, secure and private to be used by many people. For example, I talked a lot about running scalable agents on the cloud. Here is our technology for running model inference across decentralized cloud, and you can compare the inference speed to credible Web2, like centralized inference engine builders, right? So you can see the power of decentralization is not just to match what you can get in centralized, giving you a scalability as the demand goes up. And I think that's the opportunity here. Our community is also building its own foundation model, Fox, which is a small language model. That's the model that can run on the phone and empower the mobile app that I mentioned to you. And I think that's another venue for the Web3 community to own a model, and collectively we make it better and better. This model is suited for decentralized cloud, so you can train it and serve it easily across decentralized cloud. All right, with that, let me conclude by telling you a little bit about the adoption and what has been the partnerships that we have been forging in this exciting domain. Chain Opera, you can go and try the platform that I mentioned to you as an AI developer. You can also try the AI terminal. That's where you can get a web interface for interacting with the mobile application that I mentioned to you. Currently, we have more than 7,000 AI developers that are using our ecosystem, and very active community of end users who are excited about experiencing truly decentralized AI. The mobile app, AI Terminal, which is our flagship application, right? We have just released it for the test, right? It has currently 1 million plus in the test users, and soon we will make it public for everybody to use that. If you are excited to try it just right now, you can also use the cloud version. That is, you can access through our website. Finally, we are also a founding launcher of the Collaborative AI Alliance. That's an alliance across a variety of powerful projects to bring co-training and co-serving of AI agents and AI models across decentralized compute, data, and resources. I think that's going to be very important, alongside of bringing many end users and agent builders, also building the infrastructure that can be scalable, similar to, let's say, infrastructure sitting behind OpenAI that can scale to billions of users. Okay, so it's kind of we do, and through collaboration, we expand it across various layers. All right, with that, let me conclude the talk. Would be happy to take any questions.
Okay, thank you so much for presenting. I might have a couple questions that you can answer. One would be, if I was a student, if I could figure out, want to get engaged with all this, would your Discord or your website would be the best place to ask like really basic questions?
Definitely. Actually, our Discord is oriented around community, and we want to have both users and builders.
Yes, okay.
And we have a lot of community orchestrators. You can join there, and we encourage that. That's exactly the purpose of that.
Beautiful. That's what I figured. So thank you so much for presenting, and I look forward to building more on this.
Of course. Thank you.
This, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with the buffer corns grit, teaching stale protocols how to fucking commit. decentralize this. She smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from dress sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, furry, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your giant scene. Head it up to the entropy. Lace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it guitar slide. Guitar slide. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7 for time. Shaboom dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Old as speak, young as each block mine down. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with you.
back to our next speaker, I would like to present Lindsay Walker.
Hi, my name's Lindsay Walker. I am the product and strategy lead at LilyPad, lilypad.tech. Today what I'm going to be speaking about is putting your GPU to work. We're going to talk a little bit about the research that our project based our work off of, and I'm going to talk about the opportunities and challenges that I see in the landscape of what I call high-performance compute network. So LilyPad is a project that is working to make it easy for anybody to run their AI models or other type of compute jobs on a network of decentralized nodes. So the question I'm asking here, what do you do with your GPU in a post-proof of work world? Don't be like Voldemort. Harry's asking, what happened to him, Professor? And he said he didn't reach his ROI before the merge. But this is not a bad thing. It means that we have a lot of compute resources available out there. So what are the opportunities and what are the challenges for the vast network of high-performing compute infrastructure that's available across the globe? Not only in individual miners, but in data centers. What do we do with all those GPUs? Of course, the answer is decentralized compute networks. Our vision is to give users access to all the models that end users need with confidentiality and integrity. In the research that I've done, there's different ways that you can categorize types of compute networks. There are networks that do GPU rentals, so you rent it by the hour and you can configure and run what you want on there. There's also API endpoint networks. They provide the models for you. You make an API call and you get on-demand GPU compute. There are networks that bring on groups of trusted nodes, and this is honestly the majority of it right now. And there are some networks that are trying to do trustless compute. So instead of having an SLA or some kind of an agreement, they use game theory and cryptographic mechanisms to ensure that we can rely on this network. There are networks that do TEE or confidential computing to verify jobs, and there are networks that use other verification methods. And there are different projects that are targeting generalized compute, run anything you want on our network, versus specialized. They may go for a vertical like gaming or AI inference. Some advantages of decentralized systems. You can unlock a market of data centers that are sitting with 50% idle compute resources. So for any given data center, 50% of those GPUs, CPUs, whatever you may have, are not being used. Decentralized systems are dynamic. They can scale up and scale down. They're resilient and fault tolerant. If one fails, there's plenty across the globe to pick up. It means efficiency. Again, we can use those resources that we already have. You don't have to be like Voldemort. You're not wasting your compute. And blockchain brings payment rails and transparency to these systems to make it possible. So let's talk about high-performance compute. Traditionally, these clusters or networks were put together in one geolocation. It means they had really, really high networking speeds. That means that not every single compute task that we used to put on HPC clusters are great for decentralized systems because we have lower networking speed. It means we can't do instantaneous inference like a chatbot as well. There's also a lot of latency because it means we have to move the data to run, say, an AI job to the compute node that is running it. That doesn't mean there isn't a huge opportunity here. There are things that are really well suited to these decentralized systems. Anything that's batch processing. If you need to run the same inference jobs many times over a large set of data, say you have a genome and you want to use an AI model to analyze it. It's a large set of data, we're making the same call over and over, great for a decentralized network. Any jobs that's massively parallelizable, it means we can split it up across the network. And these decentralized networks also sort of have this opportunity of putting customized, uncensored, or fine-tuned inference jobs that you can't find elsewhere, which is something that LilyPad is working really hard towards. We based a lot of our work on a paper called Modicum, Mechanisms for Outsourcing Computation via Decentralized Market. I'm going to talk about what this paper presented, and then some of the things that we're using, and then some of the limitations. So the summary of this paper, it outlines a decentralized system for outsourcing computation. It's a network of crypto-incentivized actors. It deters actors from misbehaving with mediators or validators, and enforceable fines. No consensus mechanism needed for that. They're not super efficient. It doesn't require global trust, and there are decentralized roles in this system: job creator, solver, resource provider, directory, it's mostly just storage, mediator, which we call validator, and a module creator. Let's talk a little bit about what these roles are. Job creators are the end user. You will kick off a job. Usually that might be an AI inference job. We have validators. Validators check those jobs to make sure you actually ran Olama 3. You didn't go to Google and try to find the answer to it instead. Solvers match the job creators who have jobs with the compute resource providers. Resource providers are the ones who have that high-performance compute, the GPUs, CPUs, what have you. And then module creators are a pretty unique thing to LilyPad. Module creators are the ones that containerize and put the types of jobs on the network. That means you can put a fine-tuned model on there, and that module creator can monetize it. Every time that job is run, they earn a little bit of the fees generated on the network. It's a game theoretical model. We don't need to have as much security as, say, a consensus mechanism. So we don't need to validate 100% all jobs done by all actors. Most of the time, we just need to economically disincentivize what we don't want. We want to make it easiest and most profitable to just perform the job as intended. This is difficult in a game theoretic model. There's a lot of collusion that goes on. So it's not as easy as it sounded. So we've been doing a lot of work experimenting with this, seeing how it runs in real life in our test net. One thing we make a lot of use of is statistics-based job matching. So our resource providers, they have statistics, we record them, they go on chain for a lot of transparency. LilyPad job creators get bids by resource providers by price and by requirements. If you're a job creator and you want to use a resource provider, you can look at the machine specs, how much VRAM, how much RAM, how much CPU is available from this resource provider, but also statistics about past performance. How successful are you? How long does it take you to run modules? This makes it possible for the best actors to get the best jobs, but it also makes it possible for those who maybe you don't need the fastest resource provider and you're happy to pay less money for that. It makes that possible as well. We also have statistics on our modules. So again, those are those containerized and packaged compute jobs that are put on the network by module creators. We collect information about the average teraflops for the module run and the time to run a job. Resource providers use this on-chain information to calculate how much they're going to bid for a job. We have module run information, so people who are running the jobs know, okay, what's the success rate? How often does this run right? What type of machine specs does it need to run on? Resource providers also can allow list and set prices per model, or not. So these are some of the game theoretic mechanisms that we enable to enable the best actors to rise to the top and earn the most rewards from our system. Now I want to talk about why now. Why are we doing and why are we creating decentralized compute networks? Why didn't we do this 5, 10 years ago? Well, there's a lot of idle GPU. According to the United Nations University, in 2024, the global GPU market size was $634 billion. That's a lot. That is a lot of market cap. In data centers, more than half of the GPUs are sitting idle at any given time, on average. So now we have this really great mature blockchain technology. We can create more efficient open marketplaces with better prices. There's a huge demand for compute. We have the tools to do it. And we have the resources. They're sitting there doing nothing. We have the crypto and Web3 community. These are open communities that can keep up with the speed of AI innovation. I am floored every day when I hear about the new models and new agents being built, especially in the Web3 community. The Web3 community has a ton of technical talent, eager to build and accelerate the growth of the AI ecosystem. Our universal and programmable payment rails, that is, blockchains with smart contracts, are really good for things like AI agents. They don't have to, have a wallet. We can use smart contracts to enable them. Most importantly, in the last couple years, there's been huge advances in parallel processing and containerizations. The CUDA toolkit and ROCm, being able to run what you want on those, your ML jobs, your AI jobs, that's new. That's just emerged in the past 2 years. We have Docker-enabled orchestration, so it enables us to sandbox and coordinate jobs on these different nodes. And a project that we use called Bacalao enables these workloads on untrusted hardware to run across a wide network. There are some really big challenges, and that's why I'm excited for the number of projects that we have going on in this space, these deep-in networks for AI. 4 enormous things that we have to solve to make these possible, especially if we want to have truly trustless networks. Trusted networks actually are also a good opportunity as well. But we need to build a reliable, decentralized network of non-homogeneous compute nodes. That means we have all these data centers with idle GPUs, but they're not just NVIDIA. We have AMD, we have GPUs with ARM architectures. We need to make sure our network can run on all of these different types. Validating is hard. It is hard, and it's a cool problem. So if we are running a job, usually it's easy to check if you have a deterministic job. 2 + 2 should be 4. Yeah, I can check that. With jobs like AI, you put one input in and you get a different output out every time. That's what non-determinism means. It is really hard to check if you don't know what the output is supposed to be. Like I was talking about with our statistics a little bit, it's hard to build a hardened and enforceable game theoretical model so your actors are doing what they're supposed to do and getting incentivized for it. And then security is a big thing. You want to build a product, your data needs to be secure, and the modules, the compute jobs you're running on these nodes need to be secure. You don't want malware showing up on a bunch of compute nodes. So I'm going to dig into these a little bit. Building network nodes, this is really hard. In order to capture the entire GPU market, that's 634 billion, the software needs to work on different architectures and different devices and different drivers. It means we need to also, the way ours works, that game theoretic model, we need to collect information and validate from all that different hardware. That means different software for each one, different drivers. It's hard to configure, so we install our LilyPad software on each of those nodes. It means that we need to be able to configure it for each of those nodes. And then we have those modules, which are the packaged compute jobs that are sent out over the network, also must be written and configured for all nodes on the network. So this is one of the things that I'm really excited to tackle at LilyPad. We've started with certain NVIDIA architectures, but we're starting to look at different architectures. How can we make this work on everything and unlock all those idle GPUs? Validation's hard. There's different ways people go about it. I kind of look at it in 2 ways. You can do pessimistic validation. You have to check everything. You assume no one's doing what they're supposed to. You check every single job run, and it can take a lot of work. Some of the ways people do that are generally cryptographic proving mechanisms. We use ZK proofs, fully homomorphic encryption. That's when you encrypt the data going in, you act over the data encrypted, and you send the data back encrypted. Or confidential computing, where all of the computing happens in a secure enclave on your node. There's also optimistic, which is what people tend to do, just because it's less expensive computationally and energy and everything. You have to run less jobs. We assume that jobs are run correctly, but we have some sort of random challenging. We can use some probabilistic methods with this as well. You can do GPU profiling. When I run this job on this type of GPU, what does it look like? How much power is it using that when it cycles through? What are the T-flops doing? What is, how much heat is it giving off? And NVIDIA SMI gives some really great information for that, but it's a little bit harder on different drivers. Semantic validation. You check it. Does it make sense? This non-deterministic output from an AI model, does it make sense? I ask you, what is America's most popular cat? If you say Garfield, you're like, okay, that makes sense. If you give me Snoopy, semantically, I don't think that person ran the high parameter AI model I was asking for. So I've done a little research on that, and there's an interesting landscape, but it's not very big. The projects I've looked at, and this is something LilyPad is thinking about as well, have a narrow set of types of compute they can validate. Well, we want to run any job on any node. A lot of these projects only can validate like a set of 5 LLMs. I have a method for this, but it only works for these 5 types of LLMs. There's a really cool project that can check ML flows, but it's limited to specific hardware. Some projects are experimenting with ZK proofs, but these are really computationally intensive and expensive, so it might not be a good alternative. It might be if it's a big enough problem, though. The other problem, game theory. I've talked about this before. We want to prevent cheating. We want to prevent collusion. It should be impossible to game the network. Ensure if you're running a job on the network, you're getting what you're paying for. We don't want certain actors to unfairly win more jobs than others, so that's a big problem to solve, a fun problem to think about. We want to prevent collusion between actors. Some examples of what this might look like. I talked about our actors before. We have our job creators, our resource providers, and then we have validators. A validator could collude with a resource provider and unfairly just send it all the jobs. We have to make sure that that can't happen. Or the solver, the one that does, that was the solver collusion. Validating could be you validate a job that didn't actually run. Security is huge, right? Currently, a big complaint is most LLMs you use openly. You get those free credits for it. They're collecting and using your data. If you are a paying customer that wants to use AI in your enterprise use case, absolutely not even a question. You have to protect intellectual property and personal identifiable information. That means there's 3 types of data you have to protect. Data in transit, getting the data in and out of the models. Data in use, that compute has to have integrity. It has to be confidential if you're running it on a decentralized node, or you can use a trusted node. Data at rest, not as much of a problem. We, at LilyPad, we kind of just send the data and we say, we're not storing this is yours. It's yours to deal with, but we could also outsource it to a storage provider and say, hey, you guys solve this problem of storing it. We also need to make sure that models have integrity. If we're allowing these AI inference jobs to run on every computer, we also don't want it to be setting up a botnet on that computer or something else that's really bad. So we want to make sure models have integrity and or make sure that we have a really strict barrier between the models that we're running and the systems that they're running on. A couple things I'm really excited about. I think breakthroughs and advances in both of these things means that we'll be able to rapidly advance trustless decentralized networks. Fully homomorphic encryption. Like I said before, the data goes in, it's encrypted, it's acted on encrypted, it's sent out encrypted. It never gets decrypted, and the node can never see what's going on. It's really complex and expensive to compute. I read somewhere, but this was an old paper, that it's like 5,000 times less efficient. It might be in the hundreds now, but regardless, it's a lot less efficient. And there's a lot of other little details. It actually means the ciphertext, the data going in and out, is a lot bigger than the original. TEEs, also kind of known as confidential computing. It's not a secure enclave. The decentralized node running it has no access to it. There's protected keys within this enclave. The problem with that is usually these secure enclaves only work over CPUs. There's not wide availability, e.g. a big decentralized network, of TEEs that are acting over a GPU. I believe there's 2 types, like the Blackwell architecture. I forget what the other one is. There's 2 architectures that actually enable TEEs over GPUs. However, I bet you in the next 5 years, some of this stuff is going to be solved. It's going to become a lot more efficient, and it'll mean really big things for trustless decentralized networks. So yeah, I think right now we have a lot of trusted networks, which is great. It means we're offering other options over big, expensive cloud providers where you can save 60 to 70% on high-performance compute costs. What I'm excited about is when we can see trustless, secure DAI networks with advances in fully homomorphic encryption, trusted execution environments, and ZK proofs. I want to give special thanks to our amazing engineering team. These are the people solving these really hard problems, implementing this very complex theoretical paper, and thinking about all the implementation details that weren't covered. So big thanks to our engineering team at LilyPad. And I'm Lindsay Walker. I'm the product and strategy lead. If you want to learn more about LilyPad, go to lilypad.tech. Follow us on Twitter. I am on Twitter, and I'm also on Blue Sky. We also just released an API, so I encourage everybody to go test that out. Thank you very much.
Thank you so much, Lindsay. We actually have some time for questions if anybody would like to field some. There are a couple of comments on YouTube if you want me to tell you a little bit about it. So Andrew said, yes, we also need it to prevent single point of failures if a nation state or a vendor decides to censor or give unfair advantages to competitors.
Yeah, that's a great point. That's why decentralized networks are really, really great. You might be able to cut off access, but with a decentralized network, there is no single point of failure, right? There's tons of nodes out there that can still do the job for you.
Yeah, that's beautiful. And then Jay said we need to decentralize compute to ensure everyone can compete and build AI-based applications.
Yeah, and one thing that LilyPad does really well is we allow you to run any model. It's really easy to deploy any model, so it means if you it's super easy to put it on the LilyPad network and monetize it.
Okay, thank you so much for your presentation. We look forward to seeing more.
Thank you so much.
Chains. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with a do with a do with
Hi, welcome back to the Biddle stage. I would like to present Sam Green, founder of Cambrian.
Hi, everyone. So the outline for today's talk is I'm going to introduce myself, and then I'm going to talk about reinforcement learning and the types of problems that it solves. I'll then talk about reinforcement learning applications in DeFi, and I will give some tips on getting RL working if you're a builder. And then I'll give a quick introduction to Cambrian Network, which is my current focus. And just for some context setting, this is a research-oriented talk, and I'm trying to distill a lot of the knowledge that I've gained over the years on this topic for builders in this talk. So I started my career hacking cryptography hardware. I did that for 5 years, and then I went and worked on a PhD in reinforcement learning, specifically high-speed RL or low-power RL at UC Santa Barbara. I finished that in 2019, and then I co-founded Semiotic Labs. Semiotic Labs is a core dev team in the graph. We're focused on, or they are focused on, AI and verifiability for the graph. Semiotic also is the parent company of Odos, which is a leading DEX aggregator. They processed about $350 million in transactions yesterday. Semiotic is also the parent company of my new project. And also, if you're taking pictures, I have a QR code at the end of the deck, and you can get all the slides if you'd prefer to do that then. So reinforcement learning is a branch of AI that is focused on learning through trial and error. It's the inspiration for RL comes from behavioral psychology, and it is basically it's the way that all animals, including humans, learn everything. And so what we've done in RL, the computer science implementation of RL, is take models of animal behavior and basically animal learning and map it to implement it in algorithms. And with RL, you can use RL in basically two environments. You can either use simulation, where your agent can learn things in simulation, and then you can map that simulation or what you learned in simulation to the real world, or you can actually learn online in the real world, or your agent can. And as a note, you've heard of RLHF when GPT came out. RLHF is not reinforcement learning. It is a type of supervised learning where a human gives feedback to the output of the LLM. Whenever you start getting into RL, you'll see a diagram like this, where basically what's happening is you have an agent, in this case this little robot spider, that is making actions based on what we call a policy. So a policy just means a decision-making function. So an agent has a policy, you could think of it as its brain, and that policy is what determines what actions the agent is going to take in its environment. And so you have an agent that is interacting in some sort of environment, taking actions, and what happens is the environment will change whenever the agent makes actions, and those changes get output as what we call states. And most importantly, the environment will also output rewards. And the goal of the agent is to learn to take actions that can maximize its collection of rewards. So this is an example of, a recent example of using RL to train this robot that's riding a bicycle. This came out about 2 weeks ago. The policy for this robot was trained in simulation using reinforcement learning. And then after it learned how to perform these tricks in simulation, they just copied the neural network or the policy that was learned into the actual physical robot. And the interesting thing about RL is that it can learn behaviors that are at expert human level or beyond human level. And that's really for me, that's the reason that reinforcement learning is really exciting, is because it can go beyond just imitation. This is yeah, so you saw those sorts of tricks. Those are really difficult for a human to do, and really difficult for an engineer to hard code into a robot. So I like to, when I think about what reinforcement learning is doing at more of a technical level, I think about things in terms of trajectories. So if you think of what's happening for decision-making tasks, you often have to do many different things over a long time horizon to get to a goal. For example, let's say where you are in life right now is the result of many decisions, some good and some bad. And the idea with reinforcement learning is to basically pick decisions over a long time horizon that can lead to an optimal outcome. For some intuition, if you think about what's happening with an LLM, as it's generating its words, there are many directions that an LLM can go. There are many different types of sentences you've seen or code that you've seen an LLM generate. And you can think of those as trajectories. Each token that the LLM outputs, you could think of it as a decision working towards some sort of long-term goal. And in general, RL is used to try to find the best sequences of actions to get to the best long-term result. And in finance, you could think of what's happening in finance. It's not just a single decision that you're making in any sort of financial transaction. Really, you're working towards some long-term goal. Even if you buy an asset, eventually you have to sell it. And so it's a sequence of actions, even just with a simple transaction. It's not just one thing. And of course, with finance, you're looking at maximizing long-term gains, which often could involve hundreds or thousands of actions over many, many years. And so I'm interested in RL to basically maximize those sorts of actions. One more RL example, and this goes back to the fact that RL can lead to things beyond imitation learning. Remember when DeepSeek came out? The big thing about DeepSeek was that it was the first public use of reinforcement learning for training a LLM. And the interesting thing is that previously, whenever these LLMs were initially created, they were just trained on copies of human text. They were just trained to mimic all of the internet, everything that people said on the internet. But what happened during the training of DeepSeek, and this is actually a screenshot from the DeepSeek paper, is that midway through training with reinforcement learning, the agent actually learned to identify the errors that it was making in its thinking, and then readjust itself on the fly during training. And if you think about what you would find out on the internet, you don't really see people thinking through their thoughts, correcting themselves, and then continuing, because normally what people post is their finished edited product. And so you're seeing this sort of emergent behavior that happened because of RL. And it's that red text right there where that was the first time the model started actually doing something that wasn't just in the training data that was used to warm start it. So why does RL map well to finance? Well, like I said, finance is inherently a sequence of decision making. It's a sequence of decisions that are made. You are optimizing over long-term rewards. And with RL, you have what's called this exploration-exploitation problem. And in general, in finance, you have this exploration-exploitation problem. And in general, RL is really good at optimizing problems where you have to make a decision, or where your agent has to make a decision between exploring and exploiting. And so in finance, an example of exploitation would be saying that you know treasury bills offer a certain amount of yield. So you could exploit that fact to get that little guaranteed amount of yield over some time horizon. Whereas exploration might be saying, well, I know there are other assets that might have higher volatility, but they could have higher yield. So maybe an agent could decide, instead of just exploiting this low guaranteed yield option, it could go and explore and try to find other types of yield. Also, RL is good for working under shifting dynamics. So as you know, market's constantly shifting, regulations are changing, new tokens are popping up or disappearing, companies are doing better or doing worse. And so in finance, you wouldn't just use some fixed strategy usually. You would want your strategy to adapt over time. So for the next few minutes, I'm going to go into some examples of where RL is being applied in finance applications. And at a high level, we can see, I'm just going to use 3 example classes of problems where people, especially academics, have been talking about using RL. One is for algorithmic and high frequency trading bots. The other one is for robo-advisors and automated portfolio management. And the third class that I'll talk about is agent-based modeling. But before I go into those example domains, for a moment, I'd just like to talk about like who's using RL in finance today. Well, at a high level, financial institutions aren't eager to share the details of their strategies, because when they share those details, they're basically giving away alpha. They're giving away their gains. The more people that are using a strategy, the less valuable the strategy is. But we can assume that at least hedge funds have at least experimented with these techniques. These guys are hiring lots of computer scientists and mathematicians who understand these techniques really well. And we know that, but hedge funds aren't really talking about, they're not going to talk about this stuff because they're not going to give away their alpha. Banks and asset managers are publicly exploring RL, and they're publishing about it, and they're talking about their results. They're not really trying to protect alpha. They're trying to do things like basically get better orders executed and manage their risk. So they don't really mind sharing the details as much, because oftentimes these sorts of institutions, they're public about their strategy anyways. And then finally, I've been talking to some crypto projects that are starting to use RL for DeFi. So let's look at some examples of the algorithmic and high-frequency trading problem space. So these are general problems that exist today. People have solutions for this today, but RL is an interesting approach to consider for these problem domains. We'll start by looking at market making. The problem market making is basically deciding to, a market maker basically buys assets at a slightly lower price than the current spot price, and they sell those assets at just a little bit above the spot price. And they make a profit on what's called the bid-ask spread. And it is basically risky for them to hold these assets as the spot price is shifting around. And so they have to decide when to buy, when to sell, how much to buy, how much to sell, and at what prices. And so this maps nicely to RL, because they're not just looking for a single successful buy-sell decision. They're trying to maximize their profits while engaging in these pools over a long time horizon. Also, arbitrage bots. Arbitrage bots are looking for assets that can be purchased cheaper in some market and sold at a profit in a higher market. And there's execution risk, and there is competition for doing arbitrage because it's free profit, and it's highly competitive, and it's something that you would want to be automated. Finally, this trend following and mean reversion idea is you have assets that follow other assets. For example, Bitcoin follows the stock market, and Ethereum and all other assets often follow Bitcoin. So taking advantage of these statistical properties is something that an RL agent could do. So the second class of problems is liquidity provision and yield farming. Automated liquidity. So you could use RL to build automated liquidity providers. This maps to DEXs. So with DEXs like Uniswap, you basically have liquidity providers that put in pairs of assets, let's say ETH and some other token. And the risk here is that when one of the tokens is pumping with respect to the other token, then what happens is everybody sells the token everybody's buying the token that's pumping, and it leaves the liquidity providers with the less valuable token. But liquidity providers also get trading fees for providing liquidity. And so there's this complex decision process on how much liquidity to provide, what assets to provide it in, when to remove the liquidity, which will be based on the market and your belief about how the market's going to move. And this is, so RL could be used here. And then we have yield aggregation. So, you've seen things like 1,000% yield. Well, then how do yield is a common instrument in crypto. How do you determine which tokens that you would try to pursue for yield? How do you analyze the risk of those tokens? Some of that might be sentiment-based, some of it might be team-based, who's behind the project. And using AI and automated decisions, you could basically collect a lot of information you would need to manage your risk and go after yield opportunities. And finally, simulation is a big unlock for reinforcement learning. If you can simulate your environment accurately, then this is like the holy grail for RL, is the ability to train agents in a simulated environment. And as a note here, and why would you want to do that? One, you could train agents to participate for profit in protocols. Two, if you're a protocol builder, you could test your crypto economics by having both good and bad actors trying to, behave honestly and behave with extractive behavior in your protocol to see how your protocol holds up. And so these are some 3 example applications of RL, and I think right now they're only some people are starting to apply RL in DeFi, but it's very early, and I think there are a lot of opportunities for builders with a financial background to start experimenting in the space. And so I have 3 more minutes. So with now I'm going to go over some challenges with RL. We have, especially in finance and DeFi, we have behavior, sentiment, and lots of risk that's constantly shifting around. And so an agent needs to be able to deal with all of these changing conditions. You also have delayed rewards. So the longer your reward is away in time, the more difficult it is to train an agent or a policy that can go after that reward that's potentially way out in time. We have a lot of times these live markets are difficult to simulate, and so it can be hard to actually capture the real world in a simulated environment. And so your agent might have to actually learn in the real world, which in a financial setting could have a lot of risk. It's also difficult to answer what if scenarios with RL. In general, when you're doing simulations, so for example, if let's say you're dealing with some low market cap pool, then if your agent did something, it could be difficult to test in simulation how the actual market would respond in reality. So these sort of what if questions can be hard to test. Also, explainability is challenging with RL, especially with neural networks. It can be difficult to tell what a neural network is doing and why it did something. And this, by the way, is probably one of the reasons that RL hasn't been widely adopted in finance, is because of explainability. And finally, we have regulatory risk for active management of users' funds. So some tips for solving problems with RL. If you have human training examples, you should use that. You should start with supervised learning to get your hands on the data and get experience with the data. You should try classical approaches first to become familiar with how you would solve the problem generally. And then I recommend checking out some classic RL algorithms and getting experience with that. And then you can get into then you can approach the RL solution. Finally, with my 30 seconds left, Cambrian Network, what we're doing is basically we're providing high-speed financial data to DeFi agents. And so if you're building anything agentic with finance, I'd love to talk with you. And you can scan this QR code for these slides, and you can connect with me on Twitter. And I'm running a study group on applications of finance to reinforcement learning if you're interested in joining. Thank you.
Thank you so much. If there are any questions, please let the chat know, and I can definitely moderate it to him. And thank you so much for speaking. I might have 1 or 2 questions. out of all the projects you've seen, what has been like your favorite challenge and solution? Any interesting use cases that you really see to enjoy?
Well, so applying RL to finance, I can't answer it in the finance context because it's so new. There's not a lot of, other than the academic results, there's not a lot that is exciting to me. But AlphaGo was interesting. The game of, when RL was used to beat the game of Go, why I thought that was so cool is Go is a 5,000-year-old game, and RL and many strategies have been studied for 5,000 years. And RL found new strategies that experts had never discovered before. And now experts study RL and incorporate and study the Go solution for their own use.
Okay, great. Sounds great. Thank you so much.
Are confetti. They rock on PI. Get homemade in 7/4 Shaboom dose, the efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hugs flicker in the blackouts out. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottleneck's been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial-up found.
Hi, welcome back to the Biddles Squad stage, and today we have Carton Wong from ORA.
Hi everyone, how are you today? Yeah. So like a lot of people are really broke today because like the market is not doing well, but we can make it. So for make a better, but we need like a paradigm shift to really make it. And the biggest paradigm shift in our civilization right now is about AI. So today I want to talk about like what we are building in Aura and how we're going to achieve world intelligence. So humanity, intelligent monopoly, have been ended by themselves, my lady. So basically, like right now, I think the machine that we build actually smarter than we are. If you check the performance of like this logical thinking from either DeepSeek or OpenAI, like already like they can do the math and physics that already like way more than a PhD can do, like a new grad PhD or a post or a master degree human can do. So like the success of the AI, I think it's like a invincible trend, I think, because of the neuron size have been increased drastically in the past decade. So the neuron size have been increased from million to billions, billions to trillions. So I remember back then, 2015, when I started to learn machine learning, like at that time, AI model that with like a neuron network that with like 10 million parameter, that would be considered large language model, large model in general. But today, if you want to say a model is a large model, you need at least like a 10 billion parameter in your model. So what happened in this 10 year, right? What happened in this like 20 year, I would say? It's like it's not just about the hardware become like stronger. It's also about the algorithm become more advanced. It's like a co-work between human intelligence. So not just like both hardware and algorithm are developed by the smartest people on the earth for many years. And by connecting their work and their wisdom, we will have the success of AI. So we can tell that, right? Like by connecting, we can have the better, superior property. So in like 2015, like a lot of scientists have come up with like an idea called connectionism. So the basic idea is that like by connecting more parameter and neuron, we will be able to have a stronger intelligence. So, and the reality is that like today, by scaling up the parameter, we do have a stronger AI. So connection itself, emergence as superior property. By connecting atom, we have like molecule. By connecting molecule, we have protein. By connecting protein, we have a brain cell. By connecting brain cell, we have the human brain, human intelligence. And by connecting the smartest human intelligence together, we will have this artificial intelligence. And what if we connect the smartest AI together? What it would be? My answer is world intelligence. So in Aura, we try to build a world intelligence by connecting all artificial intelligence together and then have a system to let them work together and coordinate them. It's not just about like you have this like a pre-planned swarm that work for you as a company, as like an employee. It's more like have the AI as like independent existency from human. They have their own wallet. They have their own food. Like basically the food for AI is like is computation, and they have their own purpose. The most important part. So the target for us to build a world intelligence, the world intelligence should have this following property. It must be decentralized, so no centralized entity will have the control on the ultra intelligence that can be used on a bad purpose. And also it should be autonomous. It should be separate. It should be supposed to be independent from human, and it should be immortal. It means that like it should last forever. It won't go away. So for achieve this goal, for achieve world intelligence, we have invented like this multiple component to really make it happen. So the fundamental technology is that called OPML, optimistic machine learning. So essentially what we do here is like convert the AI inference into a Merkle tree and then make it verifiable for blockchain. And another important component is called initial model offering. So we can constantly use crypto to fundraise to make to have this like a novel model, because like we know that like the more diverse of this AI model we have, the smarter the intelligence system it will be. And but these two things I've introduced them in the ETH Denver last year. So in this year, what's the new thing? It's the OP agent framework. So what it does is that it enables the independency for AI agent. So we can see it as like an independent entity existency. It's not like owned by a human. It's like their own, their life is by themselves. So we know that like we have two ways in our world to manage human, like a political system. One is the communism, another is the capitalism. So in communism, it's really efficient system in a small scale. So it means that like if we get an execution order for every human, every citizen, that like you're born for doing this. You're born to be an engineer. You're born to be a farmer or whatever, and it works really high efficiently in a small scale. But it doesn't work in a large scale. So that's why we have capitalism. So we instead of like give everybody an execution order, we give them a purpose. It's just like when we are a kid, right? Like We don't know what we should do, and we are not part of the circulation of economy in our society, right? So it's fine. But once we are 18, once we grew up, and people will tell you that like your mom, your parent, your school, everybody they tell you the same thing. You need to make money. So it's like they're giving you a purpose. Most people does, and then you find your own way to cut into the society and make the money. So instead of like give AI what's the execution order, so I think we should give them a purpose. So that's why we launched the Aura token as the currency of world intelligence. In this case, we have like, for example, right? We have like my agent 1. He wanna do a business with my agent 2. My agent have like some aura in her hand, and then my agent 1 proposed this business to her. Say, hey, give me 10 aura. I will launch a meme coin for you and also kiss you. And then my agent 2 will say, hey, let's do it. If he wants it, he made the deal. If he doesn't want it, just let it go, right? And then my agent used Aura token to pay for the gas fee to any blockchain to do the transaction to my agent 1. And then my agent 1 used the Aura they made to pay for their inference and pay for the energy they use for the activity. And in this case, like these two independent systems, they are isolated from human, and they are also doing intersect. They have their own way to do like economy circulation. But anyway, but at the end of the day, their purpose is make more aura for themselves, so that they can use that for the inference. So by constructing the world intelligence, we do leverage a lot of blockchain technology to connect the AI system and connect the AI agent and use that for fundraising, et cetera, et cetera. And in this session, I want to talk about like what's the blockchain use case for AI, what we can do for AI when we use blockchain technology. So the first thing is like the new asset class. So in the past 3 months, in the past 6 months, we witnessed like the biggest like AI hype in crypto. Like we have like this like a $3 billion AI 16Z. We have this like a lot of AI agent launchpad token doing really good. And so because it's like a new kind of asset that never existed before in crypto industry. And in April last year, I summarized that into 3 kind of asset in crypto. The first one is like the model asset. The model asset is like the foundation model for AI, which is like the most fundamental thing for AI system. You need to have the algorithm, you need to have a trained model, and you need to find a way to aggregate the resources to do it. So it's a huge market here that we have not been explored enough, actually. So that's like the first kind of asset, AI model. And then the second asset class is the AI agent. A lot of us have been participating in the speculation of AI agent, although it's doing really bad right now. But like, have been asset that with some sort of a consensus, although it don't do really well because of like the utility-wise, it didn't meet the expectation of what people think it would be. And the last one will be the inference asset, the asset that generated by AI itself. So in Aura, we have done this like first initial model offering in April last year. And basically, it's like a fine-tuned, it's like an AI model that called OLM. And then it is like a basic product with like the language model. It was doing great, but it's not doing great now. But anyway, but it has been like effectively used by some people and also funded like researchers to do meaningful work. And we also have like a new IMO is coming up recently. It's the number 4 IMO. We call it like Pymalon. So basically what it does is we transfer a 2D picture into a 3D model. So in here you can see you have this like static robot, and then after you go into the model, you will have the 3D object of the robot out. So this model will be open source and start the IMO soon. And here is some preview for the IMO. So basically it's the paper for it. And another important thing you need to mention for the world intelligence is that how we can use AI to improve the performance of blockchain itself. because like AI is like basically changing every single industry in our world right now, and crypto definitely is one of the most significant one because it's like purely virtual. And one thing we can use for AI on blockchain is that we can use AI to generate more contents as an asset on blockchain. So that's what I mentioned before is the inference asset. And another thing we can use AI for blockchain is that we can use that as a true settlement. So imagine right now you have like a prediction market, but you want to settle something that's like really, really minor, and no oracle in the world actually can support that because it's just too customized and too minor. And you can use the AI searching engine on chain to settle the true for what you're looking for. And here is like the diagram how you can use the settlement, the true settlement oracle. And in here, I want to demo how you can use another Aura services. So if you go to the website aura.io, you can see here we have like, you can have like two major services here in the module, and one is called RMS. So basically, this is like a new services we provide 2 months ago. So basically, what it does is like it's the first time you can use crypto to pay for your AI API. So you can simply launch the services, open the dashboard, and then generate a key and use Aura to pay for your inference. Yeah. Yeah, probably some wrong and glitch here. No luck. Probably can try next time. And another services we are actively promoting is the AI Oracle. So basically what it does is that you send a transaction for your smart contract, or EOA, you send a transaction to a smart contract, the AI Oracle smart contract. It will do the inference for your request. So that you can have like the AI model for inference for your smart contract on chain without some centralized bottleneck, and also become verifiable. And those are the infrastructure that we need to make AI become more independent and become more like functional for the world intelligence. Thank you. Oh, and here we sorry, actually I have a last part I forgot to play. So basically here is like the video that we generate by AI about Vitaly's talking about world intelligence, but the sound is not on. But anyway, here is our website and link. Thank you.
Okay, thank you so much.
A moonwalk across gas, feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high speed, high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your pride at chomping blockchain bones. Make it down to my rodent fuck. Stealth crawl through your joint and scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing. You're just a rat with Spiral walls splinter to confetti bits. I'm curating leaps at the after party, sipping tearless tears. Call me well connected, I call it coffee for drip and the coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Old as speak, young as each block mine down. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Boodle. Oh, Pete John's got fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. No rug pulls, just pure on chain.
Hi, welcome back to our next talk. We have David Schwartz from Ripple and Camila from
The Defiant.
Defiant. Thank you so much. All right. Thank you so much, and please enjoy your talk.
Thank you. Thrilled to be here at ETH Denver with David from Ripple. I'm Camila, the founder of The Defiant, the best source of DeFi information. And this panel is all about how Ripple is increasing programmability and smart contracts capabilities. So, David, let's start by if you could introduce how Ripple is developing XRP Ledger and the XRPL EVM, and how these two will improve programmability on Ripple.
Sure. So I'm David Schwartz. I'm CTO at Ripple. We're one of the main developers for the XRP Ledger. It's a blockchain, started in the first blockchain that wasn't a clone of Bitcoin. Thank you. So the XRP Ledger is a little bit different. It's sitting somewhere sort of between in functionality between what Bitcoin does and what Ethereum does. It has more functionality than Bitcoin. Bitcoin, really, all you can do with Bitcoin is move Bitcoin around. Ethereum is a full Turing-complete smart contract platform where you can do almost literally anything. And there's advantages and disadvantages of both approaches. The XRP Ledger kind of sketches out a middle path between those two. So it has fixed function transactors that perform functions like a decentralized exchange, tokenized real-world assets, automated market makers. We're working on technology for things like lending pools, and so on. The difference is, if you have a smart contract, you have the problem of having to develop the smart contract, you have the risk associated with bugs in the smart contract, and users don't necessarily know what they're agreeing to when they use a smart contract. I'm sure you've all familiar with All My Apes Are Gone, where someone wanted to do something that they needed to agree to a smart contract to do, and they couldn't audit the functionality of that smart contract. The XRP Ledger doesn't implement its functionality through smart contracts, and so doesn't have those risks, but doesn't get those benefits either. So we're doing two things to try to sort of ease that trade-off. One of them is the EVM sidechain, which is an EVM chain that supports, the same smart contracts as Ethereum does. So if you want to do something that's easy to do in a smart contract, you could just deploy it on the sidechain and get all that functionality. But you have the downsides of that too. You have the divided liquidity. There'll be multiple DEXs that will each have their own liquidity. There'll be cost, transaction speed, and the need to agree to smart contracts to use it. On the XRP Ledger side, to get some of the benefits of smart contracts without some of the costs, we're looking to add programmability sort of at the margin. So if the automated market maker almost but not quite does what you want, or you want to issue tokenized real-world assets, which the XRP Ledger supports, but you have some unusual way that dividends are distributed, you'll be able to use smart contracts to provide additional functionality where you need it without having to have yet another chain that has a full-blown smart contract implementation with all the disadvantages of that.
Is the idea that XRPL and XRPL EVM will run in parallel, or is the sidechain, is that coming first, and then the long-term goal is to have everything move to XRP ledger?
So today the XRP ledger is fully operational. It's been operational since the end of 2012, the beginning of 2013. It originally had features like a DEX and issued assets, and then the feature set has grown over time to support things like NFTs and automated market makers and better support for tokenized real-world assets. The EVM sidechain is new. It's currently still in testing. It's going to go live pretty soon. But they will be two separate chains. There'll be asset portability between them with the Axelar bridge. As for how the future goes, I think what will happen is they'll complement each other. So asset portability will be pretty good. So you won't have to feel like if you pick one, you're cut off from the other. You'll be able to, if you have an application that really needs a smart contract, basically you have very specific functionality that's unique to your use case, you'll be able to launch it on the sidechain. And if you have a use case that's sort of more in the 85% of mainstream use cases, like everybody wants a DEX, everybody wants automated market makers, everybody wants to issue NFTs, everybody wants loans, that functionality will be on the XRP ledger. And then the market will decide, where the value and the activity is, but developers will have both options and will choose whatever's a better fit for their use case.
What use cases do you and markets do you envision increased programmability will unlock for XRPL?
I think there's a lot of enterprise use cases where it's just almost a one-size-fits-all, but it's not quite. So a good example would be a tokenized real-world asset. Let's say you're tokenizing treasuries or equities or something like that, or real estate. Basically what you're doing is the same thing everybody else is doing. You're issuing tokens, you're redeeming tokens, people are buying them, they're using them as collateral. It's all the same functionality that everybody else needs, and the XRP ledger will support that type of functionality. But you might have some weird compliance rule at the margin, or some weird identity checks you have to do, or maybe there's something unusual about the way you do votes. Maybe they come with voting shares, or when you distribute dividends, there's something complicated about the way you need to do that. I think in the short term, the programmability on the XRP ledger will solve those almost fit use cases. I don't see the XRP ledger evolving into yet another smart contracts platform that has the same advantages and disadvantages and targets the same use cases as everything else. I think the XRP ledger is going to stay focused in the short term on enterprise DeFi, and then over the next couple of years on all the retail use cases that enterprise DeFi will enable. It's kind of like what happened with stablecoins. Stablecoins are an enterprise product for enterprise customers directly. Like most people here anybody here who's used USDC, you probably didn't get it from Circle, right? You got it from an exchange, or you got it from a decentralized exchange or something. So I think those same things will happen. These enterprise use cases will enable DeFi consumer use cases, and I think that's where you're going to see the XRP ledger focusing.
Got it. So RWA is probably a big piece of this. So how are you integrating this sector?
Well, so the XRP ledger has support for tokenized real-world assets today. Ripple has lined up a number of companies like Archax and Aberdeen who are going to be launching tokenized real-world assets, things like treasuries and things like private equity on the XRP ledger with the existing functionality. We're looking to make that functionality better to enable some greater functionality based on what we're hearing that partners would like. One of the big things is better support for decentralized identity, especially for a smaller issuer. It's kind of tedious if you have to check everybody's identity yourself and you have to retain those identity documents. So we're looking at support for decentralized identity. We're looking at better support for things like, well, I have this tokenized treasury, I want to use it as collateral. And so we're looking at sort of adding more functionality to supplement those enterprise use cases.
Perfect. One of the, I think, biggest milestones, at least recently for Ripple, has been the launch of RLUSD, the stablecoin, recently in December. It already has 120 million around market cap, and you launched it on XRPL and Ethereum. So why did you decide on this dual chain approach?
I think part of the value proposition for a stablecoin, to some extent all stablecoins that are pegged to the dollar work the same in the short term, right? They represent a dollar and you can use them to move or hold a dollar in value. Where they distinguish themselves is the quality of the collateral, like nobody really knows where Tether's funds are or what jurisdiction they respond to. USDC is, better tied to a US jurisdiction. RLUSD is launched through a trust by the state of New York. And so there's that regulatory difference which doesn't change the way the token functions. functions, but it changes like its usability. But another important thing is the ability to use it sort of as a portable asset. If liquidity is just completely isolated in a small place, that makes that asset less useful. So we chose the XRP ledger and Ethereum. Ethereum, obviously, because of its market success, it's a very big place where people are using stablecoins as a DeFi enabler, not just as a store of value, but as a DeFi enabler. If you look at like the growth of DeFi on Ethereum, it's come as stablecoins like Tether and Circle USDC have been locked up. So I think like those are the platforms where people are using stablecoins. The XRP ledger has had a bit of a problem of sort of a lack of a high quality USD stablecoin. So having RLUSD on there, I think is important to have sort of like a long tail of other assets. One of the problems with only having cryptocurrencies as sort of counter currencies is they're very volatile. So imagine if you want to launch a euro-based stablecoin, and the only way you can make liquidity is to Bitcoin. Well, Bitcoin can change 5% in a day. So you need active market making to sort of peg it. And if it's a sort of a long tail project where there's a whole bunch of assets that you want to provide liquidity, you need a really high quality stablecoin to be the sort of anchor for that long tail so that you don't have a situation where the price of Bitcoin goes up a couple percent and every token just gets dragged up with it. Or, I mean, I guess it's okay when they get dragged up, the holders won't mind, but they'll get dragged down too, and it will mean that effectively when you're trying to hold a euro stablecoin, you're subject to the volatility of the cryptocurrencies that liquidity is made to. And so having a high quality stablecoin on the XRP ledger will kind of help balance that out. But you really don't want just one. I think there's room in the market for a number of stablecoins. Like it makes no sense to build a DeFi ecosystem on a decentralized censorship resistant layer one when one company is holding all of the collateral that makes all the value work. Right. So multi-chain.
Yeah, so RLUSD will enable more DeFi use cases on XRPL, but I imagine you'd also want to integrate with the Ethereum DeFi ecosystem. How do you see that, just integration with broader DeFi for RLUSD?
I hope enterprises will come to appreciate the fact that it's launched through a New York State trust, which I think is about the gold standard for anchoring a currency to the U.S. dollar. It's Ripple's been in the blockchain space for a very long time now. We have a solid balance sheet that backs the things that we do. So I hope that people will see it as a solid, option, and find that it's competitive to things like Tether and USDC. It's early days. The market is growing. I don't think we necessarily need to try to compete to take market share away from other stablecoins. I think the space is growing. I think as long as there's good availability and people are confident that it's pegged, I think it will gain market share again, because I think diversity is extremely important in building something that really is a decentralized experience.
Definitely. You recently shared an update on XRPL's institutional DeFi roadmap. Can you expand on that?
Yeah, so we've been doing two things. Ripple's sort of philosophy is that the next growth phase for blockchains is around enterprise DeFi. And by which I mean, think like stablecoins are an enterprise product. Tokenized real-world assets are an enterprise product. But they're growing on layer one blockchains for two reasons. One of them is very stupid, but it's true. It's actually cheaper to launch a tokenized real-world asset on a blockchain than through the traditional, you would have to get a provider to hold the database for you. You would have to have regular audits. Well, blockchains are very easy to audit. They're very transparent. They're very cheap. Believe it or not, a major driver for enterprise adoption for tokenized real-world assets is that the transaction fees are smaller. And it sounds ridiculous because the amounts of money that they're dealing with seem very large. It's well, it's $5 million. It's a $5 million position. How does a transaction fee make a difference? But if you're holding $5 million in tokenized treasuries, the amount of margin that the issuer is making is microscopic. Your yield is microscopic. The margins are microscopic. So we're going to bring enterprises in for dumb reasons. It saves them money, it's more transparent. They're not going to understand that it's going to do the same thing that stablecoins do. People use stablecoins for use cases that they could never use any other asset for. You can't use a non-on-chain asset as collateral for some DeFi application. And what's going to happen is they're going to learn that by tokenizing these real-world assets, all of a sudden they're going to realize that they can target brand new use cases, brand new applications, brand new user base. So the strategy is to add add the features necessary to get that enterprise adoption that paves the way for mass retail adoption. We're not going to see mass retail adoption of DeFi in the next year or year and a half because all of the DeFi applications are basically gambling. I mean, they're either recreational applications or gambling applications. If we want to take over finance, we need the really boring, I need a checking account, I need a savings account, I need a retirement account, I need a stock portfolio, I need sensible investments, I need the equivalent of certificates of deposit. We have to build all the boring stuff, and enterprises are what's going to make that possible. So the strategy is, over the next year and a half to 2 years, bring in the enterprises with these features around tokenized real. They're going to do it for dumb reasons. Some of them will be visionaries. Some of them will see this vision and they'll come to blockchains because they understand that it's like revolutionizing finance. But a lot of them will be here just because it's cheaper and faster and it works on weekends and it has these tiny little advantages that are better is better, right? If I go to you and I say I have something better, you don't have to believe me that it's going to change the world. It's enough for you that it's better. And then hopefully in a year and a half to 2 years, we can really turn that corner to sort of mass retail adoption because we'll have more than just, porn and gambling and gaming and collectibles. Not that those things are not nice. They're great. I mean, I understand the path to where you want to go is not always a straight line, right? Like the internet grew on, porn and gambling was a significant fraction of the growth of the internet. But today we use it for everything. And so the path is not always a straight line. And I don't think it's as indirect as that. Yeah. But I think the boring enterprise adoption is what we're going to need if we're going to get that retail adoption.
And to wrap up, I'd love your long-term view or vision on how that on-chain future looks like and what role XRPL plays in it.
So I think long-term, the XRP ledger is it's going to be something specific. It is not going to try to be everything to everyone. I think Ethereum, to some extent, tried to be everything to everyone, and by many metrics was more successful than the XRP ledger. I'm not knocking it. I mean, that's a great model. But the XRP ledger is is a little bit more focused around specific use cases, and in exchange, it's faster, it's cheaper, it scales better, and you don't have that risk of agreeing to a smart contract where you don't necessarily know what it's going to do. And I think it's going to retain its identity, and I think it's going to target the sort of mass real-world use cases that are going to drive volume. So, for example, NFTs happen first on fully programmable chains because someone could write a smart contract to implement an NFT, and they can get an implementation very, very quickly. The XRP ledger tends to be a little bit slower because there's a curation process by which it has to be adopted as a function. But when those functions are adopted, they're best in class. So I think you're going to continue to see best-in-class functionality for things like tokenized real-world assets, portfolios of loans, collateral, and all the boring financial products like, savings accounts, checking accounts, asset portability, and I'm hoping that that's going to give it a significant position in this sort of as tech comes to eat finance and builds new versions of all of the TradFi products, I'm hoping the XRP ledger can sketch out a big position, first on the enterprise side and then in the retail side as we get retail adoption of usable, real world, practical DeFi solutions to real world problems.
Awesome. Thanks so much, David. Exciting to see more programmability come to Ripple and XRPL.
Thanks for doing this, Camilla. I really appreciate it.
Yeah.
Test for Boodle. and fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on. Faded, just stay seated. The etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain. We led the city on sports and chains. We led the city with regen brains. We led the city on sports and chains. Rolling up and slapping chains.
She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking ether night whiz. While Lagrange rule. Grass, crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Steady-do-do, boo-boo-doo-doo-doo. Architect with a bufficorn's grid, teaching stale protocols how to fucking commit.
Yeah, that's perfect.
This, she smirks mid-flight
Testing. Okay.
as her wings tickle nodes into doing things right.
Camera's right there, so it will follow you wherever you walk if you decide to walk.
Okay, nice.
Yeah, and then I'm just gonna introduce you and then you can take this one.
Awesome, sounds good.
You watered a moonwalk
They're gonna
across
give me an audio countdown, or like,
my
so I know we're
maintenance
on.
smoother than your mom's VPN saves.
And thanks for organizing this.
Daughter of the Rockies, high-speed high priestess. Scales of justice balanced on a Memphis Express. Next bottleneck, I see mountain crush it.
Not yet. Can we play the sound? We got time.
You wanna try?
We got time to figure it out.
All right.
Now we're gonna try it.
Oh, yeah, I'm continuously pressing. That helps. Yeah. But what I'm seeing in the sounds is that ACMI is not showing. Yeah, the ACMI is not showing any output. So. Yeah.
It might be
Oh, wait. Okay, let's try again. What about now? I guess not.
Doesn't show.
Yeah, decimeter here, but it's not showing anything here. So.
Is it playing right now?
Oh, you're not hearing anything. No, yeah.
Do you hear anything? Nothing's coming in. Okay.
Yeah, I really think it's because of this. Like, there's nothing. It's all grayed out.
HDMI,
But-
decimeter, and that's
So,
for output.
for output. And my speakers show something, so it's the cable.
Yeah. I mean, the second thing is if we put it out the speaker and we put a mic up to it. Can you play? What's your loudest speaker?
Yeah, it plays from here.
Can you select audio devices somewhere?
Yeah, so we did, but it's grayed out.
Oh, right, so
it's not coming through.
Constellation stuck to the ceiling. Why? Gas fees are confetti. They rock on P Island.
Yeah, I'll just put it back. It's fine. There are worse things in the world.
I mean, it would be nice if it worked, right? So let's see if we can figure
Well, I
out
have a
something.
QR code so the audience can play with it.
Oh, that's cool.
Yeah, so like they'll still get to see it.
Yeah, it seems like your presentation doesn't have a lot to do with music, right?
It does.
So it would be a waste.
So, but I mean, it's fine. Yeah,
You can try replugging it. I don't think it's gonna do much. But usually this is the solution. We just go to decimeter, then I push the decimeter. Can you like switch it to
I mean,
speakers?
unplug and plug back in, or
Yeah, try it.
yeah, it works with regular, but not here.
Too bad, sorry.
But I appreciate you guys trying.
Okay, welcome back. Today we have Christine Walker from
Avail.
From Avail. All right.
All right. Well, hello guys. Thanks for having me here again. This is my 5th time at ETH Denver giving presentations. I'm Christine Perry with Avail, and really excited to talk to you about a workshop about how to build a music sequencer and connect it to Avail. So let's get started. The agenda is going to be pretty simple. I'm going to do a nice overview of Avail, talk to you about Nexus, Avail DA, Turbo DA light clients, and then we'll be coding a bit of the music sequencer. I'll just walk you through the code. It's only 20 minutes, so we can't like actually spin up or roll up and deploy it or things like that. But if you're interested, I'm happy to talk to you about how to do the full journey after the talk. If you scan this QR code, it will actually let you play the music sequencer from your app, which is connected to Avail DA. And so what's really cool about that is that all of you in the crowd will be able to play along as we're coding this. All right, so if you scan the QR code, this is what it looks like. You first have to put in your name and select a color, and it's really cute. But I'm obfuscating a lot of the blockchain tech because the user experience right now is not that great within Web3. And so one of the ways that I find to make it more user-friendly is to not have the person have to worry about downloading a wallet for something like a music sequencer. And so instead, all of the wallet functionality is hidden behind the scenes. Okay, so to give you a bit of overview about Avail DA, if you know about Avail, you probably know of us as being a data availability layer. But what's really interesting is we actually do a few more things. Now, I'm not going to talk about Fusion right now, but I am going to talk about Nexus. And Avail DA is mostly for rollups. So it's mostly infrastructure for rollups to be able to submit their data transactions to Avail DA and automatically generate proofs. What Avail Nexus does is it's providing an ecosystem for app developers to also come into the Avail ecosystem and deploy their applications. Think of it like microservices. So we're kind of building a really cool tool set for not just the rollups or to work with infrastructure, but also dApp developers to develop within Avail as well. Now, to dive a little bit deeper on what that means, Avail Nexus, what it does is it generates proofs across multiple rollups. And so if you've ever dealt with bridges, you've probably dealt with the UX problems that comes from having all these bridges that are deployed all over the place. You put it on the user to have to determine whether or not this bridge is safe. They have to figure out getting that native gas for that specific rollup instead of just using your app. Because you deployed your app on one chain, but you might have assets other places. We're dealing with fragmentation, and so the Nexus product is meant to solve for that. And so any rollup that is part of Nexus, what you're able to do is pretty much deploy once, but through the proof aggregation that happens on Nexus, you're able to receive proofs from other chains. So you can send assets from other chains to your user within your app. And so it kind of feels more like a Web 2 ecosystem instead of a Web 3 because users aren't jumping back and forth between so many different wallets and bridges and so forth. Now, Avail DA, again, this is what we launched with, and what it does is it provides the base layer for sequencing, and it allows you to make sure that all of your proofs are going to be validated within the Avail ecosystem through Avail-like validators. So you can kind of consider this like a layer one like ecosystem there with Nexus on top to provide a nice toolkit for developers to build on top of. Okay, now there are a couple extra features that I think are really cool. And if you scan the QR code and you played with the app, what it's using is it's using Avail Turbo DA to send transactions to Avail. Now, in practice, you really wouldn't do this. You would want to deploy a ZK Sync chain. Let's use that as an example. It would automatically have Avail Turbo DA integrated, and it would send the transactions to Avail on your behalf. For the purpose of this workshop, so that way you can understand how Avail works under the hood, I integrate it directly with Avail Turbo DA within the application. There's another product that's pretty cool, and it also allows you to post transactions directly to Avail. But what it does beyond that, I think, is even cooler, where, like clients, it does data sampling. And what that means is that you're able to prove the security of Avail, but let's say that you just want to receive only the transactions for your application, you can do that. Because within Avail, we provided a way to be able to allow you to do roll-up segmentation. And so what that means is that you can decide that I just want transactions from this rollup or rollup A, B, but not C or D, and it helps you make sure that you're not weeding through the masses of data that's already posted to Avail or any other blockchain. All right, so that's the quick overview. And so if you're interested in seeing the music sequencer code, you can scan this QR code, and what it will do is it'll take you to the code repo so you can see how things are integrated. If you're here building at the ETH Denver event, you might be able to use some of this code within your applications. So let's go ahead and go over to the code repo. So if you missed the first QR code or you're just coming in, you can simply just go to this URL here and it'll land you onto that same app. It's mobile enabled, so you're able to play a music sequence and save it to the blockchain. If you need some test ETH because you're deploying it on your own, I provided a way for you to do that. And also a nice explanation of Turbo DA and setup instructions. So pretty simple for going through that. Now, I'm going to refresh the screen, because as I mentioned, we're not having you download a wallet. We're simply having you create just a simple way to log in. And what this does is it's harmonizing. So if you've ever been to a sound bath or you've been to Burning Man, then this is sort of like a few notes that all play in really good harmony together. And what you're able to do is play a sequence and save it to Avail, which sends through Turbo DA. Once that's saved, you'll see your transaction appear here, which means that you can replay any melodies that you created in the past or you are going to create in the future. And that is the application. So to show you what's under the hood, as far as like how this is built out, let's go into the code a little bit. Now, I love Cursor. It's great. AI, yes? Oh, you're not seeing it. All right, what about now? Thanks, guys. Okay, so let's back it up, because apparently it wasn't showing on the screen. So I'm going to refresh again. Again, just go through the code repo. If you missed it, you're able to get to the URL here. You're able to understand how to deploy it. And of course, any code that's within here, feel free to use it within your applications while you're here at ETH Denver. I don't mind. But the music sequencer, again, we're not creating a wallet. We're simply signing up. So I built this for my daughter, and it's an easy way for her to simply just use an application. But if you want to create a music sequence, you simply select a few notes here, and then you're able to save it directly to Avail DA. And it goes through Turbo DA in order to save it to the blockchain as proof. So think of it as proof of music. What happens next is that you are able to play any music sequences that you created in the past. So it'll replay that music sequence for you. This is all saved on a blockchain. For this one, I am using zk Sync Era for this. And if you want to understand how to set that up, we have really great documentation on that for spinning up your rollup and connecting it to Avail DA. And if you want to learn more about Turbo DA and how that works, this is what the dashboard looks like. It's really simple. You simply sign up, you get an API key, and you're able to simply post to Avail directly within your rollup or application. All right. So to back it up, what I was going to do next is kind of go through the code and show you what's going on here under the hood. I love Cursor. It's great. It has amazing AI tools to help me build out faster. But I think what's really cool here is just the simplicity of simply connecting Avail via Turbo DA. And so what this does is it allows you to submit transactions via the Turbo DA URL, provide the data, and all you have to do is provide the API key. So as you can imagine, if you are a roll-up and building infrastructure, the setup for integrating with Avail DA is as simple as this. If you are a dApp developer relying on it, the setup is also simple as integrating with this. And that's pretty much it. So there's not a lot that goes into having to figure out how to integrate Turbo DA. Having to figure out how to integrate Nexus, we provide a lot of great SDKs to make that simple for you to be able to onboard and use the Nexus ecosystem if you're deploying an application. And so within the Avail ecosystem, we're trying to make it as simple as possible to build out the toolkits for you guys. All right. Now, I did want to spend a little bit more time on Turbo DA since I do have more time and talk to you more about what it offers. Because if you are a roll-up or a developer, what's great is that you're usually constrained by having to deal with sequential posting. And that creates bottlenecks. But what if you were able to send all of your transactions to Turbo DA at the same time? If you're not DeFi, a lot of times you don't need sequential posting, but you do need them to appear in the same order. And it still respects order, but what it allows you to do is send multiple transactions through Turbo DA within a 60-second window, and it'll provide to you an instant confirmation of proof that it will be posted. What happens after that is that once you get that submission ID back, you'll be able to visit the Avail Avail Blockchain Explorer to see all of your data that's been posted there. You're also able to use Turbo DA and the Light clients to receive or view any of the data that you've posted. And that's what I was talking about with Light clients. It allows you to just hone in on just your application data. You don't have to weed through the masses of all the other data that appears there. All right. So based off of the space, I usually allow for questions, but it might be hard to hear you guys. So I'm happy to talk to you after the talk. And thank you for attending.
Okay. Okay, thank you so much.
Some VC said this tech won't last. Another bubble, watch it crash. But we don't need your central banks. 'Cause region biddlers stacking stacks. Ether verse will leave you heated. We don't need your legacy, cause regen memes are brew of brain. They led the city on sports and chains. We've been led the city with regen brains. We've been led the city on sports and chains. Rolling up and slapping chains.
She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass. Shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Alliance architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. Eyes open, truce from trash sheets. That's my device. Nullify a sniffing bomb my copes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down, top of it, fuck. trip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lad runs lagging in his latency sub. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up from age. Old to speak, young as each block mine down. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we biddy let this city on sports and chains. We biddy let this city with regen brains. We biddy let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, good permissionless and finalized. Sport marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if you're changed.
Hi, welcome back. Today we have Dan O'Farron from EOF. Please take it away.
Cool. Yep. Happy to be here. Happy to deliver the State of Ethereum state address. I hope you like talking about state because I'm going to be stating the state. I'm going to be restating the state, and I'm going to tell you about the estate of the state. The state is probably one of the biggest talking points and concerns about Ethereum over the past few years. But you know, what is this concern with the state? First, a little bit about myself, though. I'm from Team Epsilon, which is one of the teams at the Ethereum Foundation. I just started there in January. I've been a long-time contributor to Ethereum. I have been to every single ETH Denver, including the one they did online in the pandemic. So I love this place. I think this place is great. So first, we need to talk about what the state is. What is the state that we're worried about in Ethereum? And it turns out it's the data we use, and a lot of data about the data we use. And that's really where the problem comes in, is a lot of the data about the data and a lot of the history. So we're going to talk about the chain data and how we bring that data onto your device. Now this eye-popping chart, yes, it's going up to the right. This is probably what we want, but this is not what we want going up and to the right. And that is the size of how much data you need to store an archive version of an Ethereum node. 21 terabytes tracks the total size of everything related to the Ethereum node in the past nearly 10 years that it's been running. Very few people have 21 terabytes on their Ethereum node. This is tracking literally every piece of metadata about it that could possibly be calculated and needed. Now this is a probably more realistic chart. This chart is showing what a full Ethereum node is tracking. You'll notice that the black line on the bottom is parity. Parity stopped working at the time of the merge, and it's a fairly flat growth. And the blue line is Geth. Geth had some pruning issues with some of the data that it was keeping that it didn't, but eventually last year it figured it out, and now it's a nice, slow growth line up and to the right. And you see right now it's about 1.25 gigabytes of data. Still a lot of data, 1.2 terabytes actually. Terabytes of data. Terabytes was the right word. 1,000 gigabytes, and that's not necessarily a good thing. So why do we need all this data? What is all of this data, and what is it all about? So if you think about the things that you use in Ethereum, your account, your balance, a particular state value that you need, think of those as a number with a path to a location of where it stays. I am this number in this account, and I represent 25, and I live here. These things we call leaves, and they live at the bottom of a tree. So we take all these leaves, we arrange them in a tree, you put them in the bottom of the tree, and we can't just transfer however many gigabytes of data to say this is the current state. We need to reduce it to a smaller number. So we do something called a Merkle tree. We hash this value together as we go up in levels. So the first level will hash the lowest level of trees, the lowest level of leaves, and we'll get a branch value that represents that. There's fewer of those. When we go up the next level, there might be a leaf in addition to some of those branches. We wind up with fewer values. And we keep going up, and we keep hashing these branches together using a hash function until finally we get one number that represents the state of the Ethereum network. That is a number with 256 bits in it. It's got about, I don't know, a whole bunch of zeros. It's a really large number, and it's unlikely that you're going to find the same number twice, which is what makes it a good number. And they use a very secure hash number that when you do the math, it's going to be really hard to reproduce with anything that is even remotely the same. So this is what we do when we calculate the hash, when we pass the block headers around, we reduce it to one single number. So how could one single number result in so much data? It's because when we change the data, we also need to change all the branches above it. So in this case, if we change two leaves values, we then need to recalculate all the branches above it and the root node, which isn't that bad if you do it once. And if you're a full node, you just keep what you need that's relatively current. But if you're an archive node, you need to copy that data to the side. And those same two values change again, you have to store it again, and again, and again, and again, and again. So you got this big giant pile of tree branches of every time in the history that this value has ever changed and all the metadata around what the actual root node of it is. So archive nodes track every single one of these values throughout the entire history of Ethereum, whereas a full node just keeps a relatively short list of maybe the past few days. So this is a lot of data. And the next question is, well, how do we synchronize this data? There's principally 4 methods. The first one isn't really used that much. It's where each of the client goes around and they take that root node, that value, and they ask all the other clients, hey, tell me the children. And then they get that branch value and they go, hey, tell me the children of that. And they start at the bottom of the tree and they go all the way down to the bottom of the tree. So they go from top to bottom syncing it. And this works great in small numbers, but when you get to a real full production size mainnet experience, this can take days to calculate. And the problem is that clients like to clean up and keep things nice and tidy, so that root node that you thought you had around, there's going to be less and less clients that are going to be able to share that information. So the problem is when you do this fast sync, and it was faster than some of the alternatives, is you're eventually going to run out of references to that root node, and no one's going to be able to tell you what your tree leaves are. So a number of years ago, Geth came up with a better idea called Fast Sync, and Besu and Nethermind also implemented it. And the difference is you start with the leaves at the bottom. You just say, hey, just tell me the leaves are. Give me the first 10. Okay, give me the next 10. And you keep moving left to right across the tree. And as time progresses, you just say, give me the current value of that. So as you go left to right, you don't have the leaves at the same point in time. You have them over an increasing point in time, but eventually you have all of them. And once you think you have all of them, you add them up, you do the hash, you get a root value, and spoiler alert, it's going to be wrong, but that's okay. Because that's when you start the next step, which is the healing step. You basically do a fast sync from this top, and you start asking for that number, and you ask for the branches below and below, and eventually, you're going to find an entire series of branches that you already have. It's going to save you a bunch of time. You don't sync that. Surprisingly, small amounts of the database actually change over the number of hours it takes to sync it. So this goes relatively quick. Another important step while fast sync and full sync are going on is while you're downloading these branch datas, you're also downloading the entire block header and the block history of Ethereum. The list of all the transactions that anyone has ever executed is being downloaded in parallel to this tree data. And that's very important to realize. The tree data and the transaction lists are 2 separate items. We'll come up to a chart on that later. Now, TreeDBs are not the only way to store this data. Aragon has its own style of database that Reth is duplicating. So they can't do this fast sync. Instead, they got to do a different kind of synchronization, which is basically got to replay from the beginning. And that can take a long time if you calculate all the branches of every single block. So Reth and Aragon optimize it, and they don't calculate those values. They just download the values, run everything to the end, and at that point, they calculate the root node. And if you do everything right, the number is going to be just fine because it's tracking and making sure that you've been doing everything correctly. And again, at the same time that it's running this, it's got to first download all the blocks. And it tends to, the block download tends to go faster than the actual execution. There's one way that nobody really does anymore, and it's basically a variant of a database copy. Parity used to do this. They take their current database, they dump it out to a file, and then everyone would download that file and extract that out into their clients. It worked great until the blockchain got too big, and it got to the point where the amount of time it took to export this data was longer than the amount of time they had to export it before they had to reseed it again and get started again. So that sort of a database snapshot technique really isn't used before. So once you run all this data, once you synchronize all this data, what are we looking at in the blockchain? Well, if you have an archive node, the archive branch data takes about 20 times as much data as the rest of the chain. That little slim circle in the middle, that's the current full node data, and all that green circle around it, that's an archive node. So when you look down deeper, and what you really get is you get quite a different story. The actual data that represents what you're calculating, the account state, the storage state, and your code, takes up only 5% of the data. 15% of the data is that metadata of the tree that holds it up. So 80% of the data is literally just the list of all the transactions that Ethereum has had for the entire history of Ethereum. If you're following the rules. If you're not following the rules, you can chop it off. But the rules right now say that you're supposed to download every single transaction for the whole history of Ethereum. And that's why the blockchain keeps growing. That's why people freak out when you say, when you increase the gas limit, we're not going to be able to handle the data. The data is not the data on chain that you're using at the moment. The data is the entire historical ledger of Ethereum that we have to download if we increase the block size. Now, why would we want to increase the block size, and what are some of the things that have been done to deal with this? So in that, we start talking about layer 2s and blobs, because a lot of the use in Ethereum in the past couple of years has really exploded on layer 2s. And layer 2s have a voracious appetite for transaction history. Here is a graph of the number of user operations since the dawn of L2s. For a long time, there was less transactions that were on mainnet, and then there was a bit where it crossed over, and then over the past 2 years, it's just absolutely exploded, and it's just gone bonkers. Now, one thing to pay attention to, that last little green diamond there on the right, that is when Denkun activated, and where the most important thing to happen into the L2 ecosystem happened, blobs were activated. And you can see that there's an immediate tripling of the amount of user transactions that were done in that time because everything became that much cheaper and everyone were just excited to start using it again. And it fell off, but then it's come back with a vengeance. You can see that it is 16 times as many transactions happen on layer 2 than happen on layer 1. This, in some ways, is the absolute fulfillment of the rollup-centric roadmap. We're doing more things not on the main chain, but on layer 2 chains. And what's interesting is when you look at that growth, the gas limit for Ethereum has really remained static for the past 2 years. On average, there's 15 million gas executed per block. It can go up and down. There's some floating fee market stuff that goes on with it. But on average, it's going to be 15 million per block. And for over 2 years, since the merge, we haven't touched it till about a month ago. And last month, we updated it to be about 18 million gas per block. So that little blue bar at the very end of that is the same. So the gas has been flat. But you want to talk about the gas? Let's look at the size of the average block over that time. It tells an entirely different story. 2 years ago, it started out at a reasonable level, and it kept going up, up, and up. The reason is because Layer 2s had to store all of their Layer 2 transaction data on the Layer 1 blockchain as call data. They had to put all their data in the transaction to be a real Layer 2 to have the Layer 1 track all of their data. So you can see that the values went up, up, and up, and it peaked at about a quarter megabyte of data in January. And then you'll notice that there about March, it absolutely went down like a rocket slide and went back down to more reasonable levels that we've seen in the past. And this is when Cancun activated, when all the Layer 2s stopped posting to Layer 1 and started posting to blobs. Blobs are a different kind of data. They're just random data that is associated with a particular transaction that we don't have to keep around as part of the main history. Blobs have to be kept for 14 days on the consensus client, and then the consensus client can keep them or dispose of them as they see fit. They're only responsible for retrieving them for 14 days. And when we target 3 blobs per block on average, what that means is you need to take about 36 gigabytes of data on your consensus client to store these blobs. So that means we're transacting in nearly a terabyte of data in blob data. And then that's for Cancun. In about a month or two, we're going to fork Pectra, and we're going to double that number to 6 blobs per block is what our target's going to be. And what that means is that you need to keep 73 gigabytes of data on your hard drive, and it's going to be nearly 2 terabytes of data per year of blob data that's going to be processed. But remember, your consensus client only has to keep that 73 gigabytes of data. We don't have to keep the entire history of every blob. That's the Layer 2's job to do that, and we put markers and hashes in the blockchain so they can prove that their blob did exist at that point. Some really fancy KZG moon math. Now in Fusaka, ideally we're going to launch it this year in the Q3. There's a couple of ideas of what we're going to do. One idea, the very simple solution that we know we can achieve, is just to go up another 3 blocks, target 9 blocks. And that means we can have about 120 gigabytes of data. It takes about 3 terabytes of data. The more exciting answer, though, is something called PeerDAOs. And if we do PeerDAOs, we can go for a 6x, 8x number, 48 blobs. Now, in some of this math, you'll notice it looks like I'm doing it for 96 blobs, but that's because they do some erasure data, some magical moon math to make sure that it works right, so that you only have to store about 200 gigabytes of data on your block, even though we've gone 8x on it, it only doubles. And so this provides an average throughput of 30 terabytes per year of blob data that can be stored on the Layer 2 blockchain. So what is PeerDAOs? That's a 20-minute talk in and of itself. But I think this picture really gives you an idea of what it is. Each client only keeps a subset of the blocks, and the subset that they're responsible for keeping, they have a little sub-network of other peers that they talk to, that they can get the data and share amongst themselves, so that you know who you're sharing it with, and you can make sure that each other is keeping, you can challenge it, and you can get different pieces for it. And they use advanced erasure encoder mechanisms. Now, one of the things to note that this is not the final evolution of blobs on Ethereum. This is step 2. The third step, full dank sharding, these columns, they become simple squares. So it's 2-dimensional, and the number that I've heard thrown around, I don't know if they're going to be able to achieve this, but this is the goal they're going for, 256 blobs per block. That's a lot of data. I didn't even do the math for that. I mean, I might need more than terabytes to track that. So what this comes down to on a consensus client is you only need right now 95 gigabytes of data to run a consensus client on your node. The blobs cycle through every 14 days. The finalized slots, not quite as rigorous as the 14 days, but they don't have to keep all of it. So the size of the finalized block stays pretty constant. It's not going to grow like it does with the block history. So what they've done in consensus is they've got a very consistent target that this is what you're going to have to keep. And it's going to be fairly static. It's fairly predictable. We know what it's going to be. It's not going to grow without bound because we can prune the data. So consensus layer really has its act together. What can the execution layer learn from what the consensus layer has done? And that's going to come up in EIP 4444. Now, blobs had its own number, 4844. And I guess they like fours so much that they went with 4444. 4 fours, to really emphasize this next, it sounds complex, but it's a really simple solution to what the execution clients are going to do to maintain their state. They're just not going to keep it. These 2 bullet points is basically what the entire specification of EIP 4444 is. If the data is more than a year old, you should not serve it. And if you're not serving it, you may prune it. If you're not going to tell anyone about a transaction back in 2019, you don't have to keep it around. So whenever you do a peer-to-peer query, if you ask for something older than a year, no one's going to give it to you. If you ask for a block, a RPC for something that is back in 2022, the RPC is not going to do that for you. Now, you can if you want. It's only a should. If you deliberately do it, you can do it, but no one can make you, and no one can punish you, and no one can blacklist you as a node if you refuse to serve stuff older than a year. That's what 444 allows. And what happens if you take all that more than a year old data and you prune it away? You throw away just basically a terabyte of data that you no longer need to keep on your client. It takes the amount of data that you need to do, and it cuts it by over 2/3. So what used to take 1.5 terabytes now takes half a terabyte. And what's amazing is if we don't do anything with the block gas, which we will, but if we kept block gas at the same level, those numbers would stay relatively consistent. The only real growth we would get is in new accounts, new balances, new tokens, and those grow at a much smaller rate than just the raw transactional history. So it still has a possibility to grow without bound if everyone uses the blockchain without bound and we have to keep all the data. There's a plan for state expiry that probably going to have to deal with in a couple of years. But as we can see, it's still the smaller portion. The tree branches that track that data is bigger. And the amount of your blockchain history is, it's not even as big as the rest of the data now. It's a really great solution. It's really subtle, and it has powerful impacts. But what about all that data? Does it just go away? Does it go in the bit bucket? How do we get the entire history of transaction of Ethereum? It's kind of important stuff. Oh, before I get to that, though, when are we going to pull the pin on this? We're going to pull the pin on this feature, not as part of a fork, because it doesn't require a hard fork. We're just going to do it on an agreed upon day. And the day that the clients agreed on in the execution layer is May 1st. Mayday, mayday, mayday. We're going to get rid of 2/3 of the data, and it's going to be awesome. Unless you need that data, so you need to download and sync it quick. Actually, we got a better solution to that. Another thing that deserves its own 20-minute talk is something that Piper Marion's been working on called the Portal Network. The Portal Network is going to keep all of this history for you in a separate peer-to-peer network with separate cryptographic incentives, and it's going to make sure that this data is still available. And it stores more than just the block history. It's going to store the state history, it's going to broadcast transactions, and it's designed actually to support light client execution, real light client execution, the sort of stuff that we are looking for witnesses, except you're not going to need witnesses. So if you access the Portal Network, you can actually execute some of your transactions without having to download an entire blockchain. There's a whole raft of clients and everything that you can look up if you go to their site, ethportal.net. But like I said, it's an entire 20-minute talk in its own right. So I'm here to tell you that the state of the Ethereum state is strong. It's been a very powerful changing force in the world, and it's not going to hold us back. We're still going to be able to remember all that we had. We're going to be able to maintain and take care of the state that we need in the future. We'll be able to grow responsibly. With these changes that we're doing in EIP 444 and 4844 with blobs, and with restricting the size of the blockchain, we can increase block space, we can increase gas limits, and we can make sure that our clients will not run out of disk space unpredictably. We'll be able to make sure that everyone can serve the state, can make use of the state, and can prosper from what the state provides. I mean the Ethereum state, not the government state. They're kind of the opposite level on that. But again, this data is good.
Yeah. Thank you, Dano. Appreciate your talk. It's very informative. Excellent. Okay, so we're taking a short break. Thank you guys.
Few chains choking ether night whiz. Found her at a bullet hook, sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass. Shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Da-do-do-do, boo-boo-doo-doo-doo, boo-doo-doo-doo-doo, Alliance architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do with a do-do with a do-a-do-a-do with do-do-do-do-do-do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing on my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Pan it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it guitar slide. Guitar slide. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. drunk bumblebees on the bumblebee. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future.
Hi, welcome back. We have Sean from Parity Technologies to talk about the future of Web3. Why don't you take it away?
Yeah, testing? Oh, great. Hey, everyone. It's so great to be here at ETH Denver. It's definitely my favorite conference in the US. It's such a good vibe, and it's so nice to be surrounded by developers and builders. So that's kind of what we're going to talk about. We're going to talk about the future of Web3 and what that means for builders and developers in the ecosystem. First, a little about myself. Before I worked on blockchain, I was studying physics and math at UCSB. I then worked 4 years at Azure and Microsoft, and then I basically learned about Ethereum, and I kind of went down this rabbit hole I'm sure all of you have also gone through. And basically for the last 7 years, I've been working on blockchain development. It started, of course, with smart contract development on Ethereum, but then I joined Polkadot, and I've been working on Polkadot for almost 6 years now. And I've, in addition to doing development, I also am an educator and teacher for Web3 development and blockchain development and all that kind of stuff. I think it's important to address, especially in this current time, that there's a growing divide in the blockchain ecosystem. I think there's a lot of, especially if you've been around in the space for a long time, you have this feeling of people who are actually building for the long term. I definitely think Ethereum is one of those people, but also a lot of other projects popping up which are really having like a focus on short-term results. They're trying to figure out how they can basically get their blockchain or their system to mass adoption tomorrow. And that means often cutting corners, doing things like end-event multi-sigs, small validator sets, using high-powered nodes, all the things they can do to basically try to capture the current mindset versus trying to think about what really scales and what actually grows a Web3 ecosystem. And I think a lot of this divide comes from basically a misunderstanding of these terms. We use all these terms kind of interchangeably: cryptocurrency, blockchain, DeFi, Web3. But in fact, these terms are not the same at all. It's very, very different. Cryptocurrency is just a resource. It's just one of the things that's produced by this Web3 space. Blockchain is just a technology. It's a tool you can use to actually produce Web3 resources. DeFi is just one of the verticals in Web3. But really what I think we're all here for, what actually attracted me to the blockchain space, is Web3 itself, the revolution of what we can do and change in the world. So before I even get into that, I want to talk about why this presentation is relevant for the Ethereum community. It seems that, in my opinion, that Polkadot and Ethereum are both really building towards the long-term mindset. I think that's great. I think that's really awesome. And it seems that Ethereum is heading in the direction that Polkadot kind of already explored. I mean, right now we have this forum post, which I think everyone has been really liking, January 20th, 2025, where we're trying to head towards this native rollup solution. And I would say arguably Polkadot has already built a native rollup solution. So I wanted to share some of the experiences we've gained, some of the insights we have about how this works, that it is pretty good, but how we can actually go deeper and further than that. So yeah, my goals are to remind you and remind everyone about the meaning of Web3, to explore our native rollup solution so we can give you some insights, and also share insights into how that can evolve into something bigger, something more powerful than just blockchain, something like a Web3 cloud. So first, what is Web3? I think in one sentence, Web3 is the technological embodiment of the idea of less trust and more truth. And why are we afraid of trust? Why should there be less trust? Well, I think if we know this quote, absolute power corrupts absolutely. If you read the whole thing, power tends to corrupt. Absolute power corrupts absolutely. Great men are almost always bad men, even when they are exercise influence and not authority. Still more when you super add the tendency or certainty of corruption by authority. We have seen for years that corruption and authority are one in one. And if you look at just the history of blockchain itself, you will see that exact same problem. Back in 2008, this was the catalyst for Bitcoin to exist. We had the global financial crisis, the corruption of banks that was then bailed out by a corrupt government, by centralization. We had the WikiLeaks censorship, where basically banks were taking their power to stop WikiLeaks from getting funds to be able to do their job to basically give information to the world. And then one of the catalysts for Ethereum was the Snowden revelations, right? The fact that we learned that the NSA was basically running a global surveillance firm across the entire world and was capturing this data without our consent, right? These kinds of systems have shown us that centralized authorities cannot be trusted, right? And Web3 is the solution to that. Web3 is a set of principles and properties which provide more truth, right? Web3 is decentralized, verifiable, self-sovereign, interoperable. You can read all these things. This is the kinds of technologies we want to create. And again, what I'm really concerned about is that in this space where we have people with short-term mindsets, they forget what we're actually building towards. Blockchain is just a technology. Just because you build something on a blockchain does not mean you are Web3. Web3 really comes from the having all of these properties, and some of these can come from blockchain, but more importantly, it comes from many other pieces and parts of the technology stack. So Web3 is really a revolution in the way that we interact with the world. And I think this is super important and a fundamental starting point for how we should talk about anything in the blockchain space. Now, what's kind of sad to me also is there's such an emphasis on DeFi in the blockchain space today. If you look at kind of all the way people talk about blockchain, all the way people are adopting it, it is just DeFi, DeFi, DeFi. But we know, following these principles, that centralized authority and corruption is not only found in finance. It's found across all the different technology stacks, all the different verticals. We need to explore much more than just DeFi to really unlock the real future of Web3. Now, DeFi, I admit, is very, very important. It is absolutely a key part of how we're going to achieve a Web3 future. But we need to explore other verticals as well. And I want to clarify that. There's no reason we can't do that, because blockchain is just a design for a decentralized computer. It is just a protocol which takes many computers around the world, puts them together, and makes a decentralized computer that you can access. Now, if we look at the history of computers, early computers were also just used for finance. The very first computers in the 1950s, they were adopted by banks and other governments to basically support financial transactions. These are basically simple calculators, right? But we've seen as the evolution of computers have gone on, we've adopted things like business-specific servers, on-prem servers, and that has led to things like the cloud revolution, where now if you want to access or deploy something into the tech world, you can basically use other resources available in the cloud and deploy it. One of my arguments about the future of Web3 is that we will follow the same kind of pattern in the blockchain space. If you remember, early blockchains like Bitcoin and Ethereum are basically being used just for finance. And we are already seeing a huge adoption of new business-specific blockchains. Think about how many new blockchains are coming out all the time, whether they're L2 or L1, and how many of them are just basically trying to attack a specific idea or a specific narrative. Well, the next natural step then is the decentralized cloud revolution, and access to a decentralized Web3 cloud where basically you don't have to launch a new blockchain to be able to access a Web3 application or to launch a Web3 application, that you can actually just host it on existing Web3 resources in a cloud. And so this is what Polkadot is aiming towards. We are aiming to towards the next evolution of this blockchain landscape, the next step in the evolution, right? So if you really say that Bitcoin created a calculator, Ethereum created a computer, Polkadot is creating a cloud server. And I think, simply said, that we want to do to Web3 what AWS did to Web2, which is make it cheap, easy, and scalable to launch applications into such a cloud. And of course, if we talk about what the difference between Web2 and Web3 is, it really is resilience, right? If we want to build a better internet, we need to have a more resilient internet. And so that's an internet that is resilient against censorship, corruption, network outages, hacks, and all the above. Now, these ideas are not new. All the way back when Gavin Wood, if you haven't heard of him, he's the original CTO of Ethereum. He was the inventor of the EVM, author of the Yellow Paper. He was the person who originally envisioned Ethereum as this ubiquitous world computer. But this is a narrative I find that's dying. I find that less and less we're talking about Ethereum as a computer and more as a settlement layer for transactions or a roll-up layer or whatever. I think we need to go back to this idea of building a world computer. And this is what Gavin is really trying to do in the Polkadot space. So, I want to talk about the building blocks for native rollups, the things that Polkadot has already explored and where we can go from there. So the building blocks for native rollups, as described in the Polkadot paper, are these four things: parallelization, shared security, interoperability, and data availability. I'll go through these things really quickly. Parallelization basically allows us to scale out, to scale horizontally. Using data and execution sharding, we can execute multiple applications at once, multiple programs at once, and have them all parallelized. If there are two contracts which aren't interacting with each other, there's no reason why we have to block them on each other. Right now, a lot of the existing L1 blockchains are still serialized, and moving towards a sharded solution, like what we're seeing with L2s, is really great for scaling. Then, of course, we need shared security. It's not enough to just have a bunch of blockchains run. All of them need to be secured. And it's not really scalable to have each of them have their own independent economy to secure their blockchain. So what's really nice is that we have a platform that can provide security to all the other blockchains, like what L2 gets from L1. Then, of course, we need to think about interoperability. If we're going to expect a lot of different applications running on these blockchains, we need to have them talk to and interact with each other natively. And this is not something that we can design after the fact. And we actually look at a lot of the current conversations in the Ethereum space are talking about how we can bring native interoperability to L2s, right? And of course, data availability. We just had a presentation right before me talking about data in Ethereum and how it's super important, that data availability, that we have the ability to store some data, which is only used for a certain small period of time, but is not stored in the permanent state. Data availability is a key part of what makes rollups work and scale. And so this is another key part that we've introduced inside of Polkadot as a native part. And we're starting to see Ethereum do the same in their rollup-centric mindset. So, what can we achieve, or what have we achieved with this native roll-up solution? Well, Polkadot has achieved the highest levels of L2 scaling by having the most data availability bandwidth. So if you look at any of the data availability solutions, including Ethereum itself, we have the highest bandwidth across all of these solutions because we have designed our system with this in mind, with the fact that we want to support roll-ups natively in our protocol. We also have been able to achieve the most resilience. We have the highest Nakamoto coefficient because of the way that we treat our validators and our staking system inside of Polkadot. This higher Nakamoto coefficient means more decentralization, more resilience, a better platform for rollups. We are also the most energy efficient. This really comes from a lot from our staking, a move from, obviously not using proof of work, but using proof of stake, but also our parallelization. Having different applications run in parallel generally means that the main blockchain itself is not always using all of its throughput on every single process. We're actually able to parallelize and get more efficiency. The exact same way you would expect to get more efficiency across your computer or your phone, having multiple cores. And finally, we have been able to achieve and show that we have the fastest TPS across any blockchain in a live production network. We were actually able to run and have 140,000 transactions per second on a live network. This is not something that was like hypothesized, or this is not theoretical. This was actually running on the network, which is far surpassing all the other blockchains out there with their theoretical claims. Now, I want to really quickly say that, this is not trying to shill Polkadot, I mean, obviously a little bit, but it is trying to show that a native rollup solution is really great. It works. And we've actually already seen that 10 of the 20 top rollups in the ecosystem are powered by Polkadot. So the direction you all are going in Ethereum is good, and you'll actually see a lot of benefits from it. For example, getting high volume with low fees. When you go to this native rollup solution, you'll be able to process transactions without having other applications interfere with each other. They will all be able to scale on their own time and not have to affect the fees of the other applications. This will be better for the application developer. So all of this is just saying the native rollup solution is great. I think you all are going in the right direction. But we've already built this, and we're headed now in another direction. What is that direction, and how can I convince you that this is the kind of the path we want to take? How can we take this native rollup solution and build a Web3 cloud? So let's look at the building blocks for Web3 cloud, right? The first building block is that we should focus on building a computer, not building a blockchain, right? A blockchain is just a tool. It is just one of the pieces that we need to have Web3 properties. But we should focus on building a computer so that any kind of application can use it. Then we should focus on block space, not TPS. Transactions don't mean anything anymore. You can have a transaction which is transferring some token. You can have a transaction which is calling a smart contract. You can have a transaction which is securing a rollup. Transactions don't mean anything. What we really care about is block space. This is the resource generated by a blockchain computer. And then finally, we want to make it accessible to everyone. We want to make sure that this resource is accessible and usable by anyone who actually wants to use it. So, we have designed an updated computer. If you want to check it out, there's this idea called JAM. This is basically a new specification for the Polkadot ecosystem, which is designing a new, scalable, decentralized computer. It will increase the performance of Polkadot network by orders of magnitude, and is being implemented by 35 independent teams across 14 programming languages. You can go to the gray paper, and you can actually read this specification. This is exactly like the specification that Gavin created for Ethereum in the yellow paper. So this is a design for a new, decentralized computer. And this computer is a multi-core computer. And I would argue it's the first. This is the big key innovation. When you look at Ethereum as a computer, you can really think of it as a single core system. It processes transactions block by block, one at a time in a single core. We saw that the evolution of computers was moving from single core systems to multi-core systems. And this is the design for how you would build a decentralized multi-core computer with hundreds of execution cores. This is a computer that's focused on block space, right? As Chris Dixon has pointed out, block space will be the best-selling product to be selling in the 2020s, right? That block space is really the accumulation of resources generated by a decentralized computer. The quality of this block space can vary depending on how good the computer is. And we're really designing Polkadot to focus on creating high-quality block space. And this is a computer that is designed to help you scale. So we have implemented in the computer itself a pay-as-you-go model, which allows you to access the computer only when you need it and pay only when you need it, and also have elastic scaling. As we mentioned, we have multiple different cores. You can actually use more or less cores as you need, just like you would expect a computer program, right? So if you have a program that's very intensive, it needs more than one core to run, you can access it. So you can actually have programs which scale and use lots of resources, pay more money, or use less resources and saves you money. This is exactly what you expect from a Web3 cloud, a well-designed computer. Now, one of the really key innovations in our new specification is this thing called the PokaVM. This is a brand new, reimagined, redesigned virtual machine environment. It uses RISC-V instead of the WASM or EVM. It's easy to transpile to common hardware like x86. It has near-native speeds, cheap gas metering, and a very fast compilation. If you want to learn about the PokaVM, you should check out this link over here. But the key thing I want to talk about is that it supports this thing called continuations. And this allows it to do things like run Doom. Like when you think about building a computer, when you think about building any kind of computer system, running Doom is kind of the base level bar of can it do that? Because of continuations, it can. So I want to spend a little time talking about that. So what is continuations? Continuations is like a save state. It allows you to continue execution after pausing. So in the blockchain space, you can start an application or a program. You can run that program until you run out of gas. You can save the stack, the registers, and all the memory, and put it in the data availability layer. Remember, this is not persistent, right? This is something that's just stored temporarily. We can wait until the next block, load all the information, and continue running the program. This changes how we actually build applications. The old paradigm was if you wanted to build a Web3 application in the past, you would have to design the application with the blockchain in mind. You have to build the application so that it can run piece by piece, and then you can actually load it into the blockchain and run it block by block, right? This makes blockchain development very specialized. It means you can only basically run smart contracts or other blockchains. What we would want to see is the way it should be is you should be able to build an application and just run it in a cloud. If that cloud has Web3 properties, you will inherit those properties, right? And so what we've done with the Polkadot Cloud and with PokaVM is basically allow you to run any kind of regular x86 program. Any program that you run, even if it has a long-running program, more than one block can handle, you can just build it, load it into our cloud, and in our backend, using continuations, we'll be able to run it on the blockchain, right? So you as an application developer don't have to be exposed to all the intricacies of building apps. You just build an app, and we make sure it's secured by a Web3 cloud. So we've already built this platform for securing rollups. This is good, this is great. But the next milestone, the next place we're thinking about is how do we build a platform for any kind of decentralized Web3 application? The PokaVM is also Solidity compatible. This is really exciting. So all of the existing Solidity contracts, we basically compile them, recompile them to Yule, and then Yule to RISC-V, and we can run them in PokaVM instead of EVM. And you can use all the same tooling as you'd expect on the PokaVM. So you can use like Remix or Ether.js. All those toolings are available in this new VM environment. And we've used this new PokaVM not only to bootstrap the cloud and our main Polkadot platform, but also to create a new product, the Polkadot Hub. The Polkadot Hub is a Polkadot native, elastically scaling, Solidity compatible smart contract platform. And it harnesses all the power of the Polkadot Cloud. With the Polkadot Hub, as this platform for smart contracts needs more cores, it can elastically scale to use more cores on the Polkadot Cloud. It can actually scale up without having to limit people and have transactions be not censored, but like bottlenecked or limited to actually get into the block. We can actually use more cores and get more throughput as we need. And if there aren't a lot of transactions happening, then it also scales itself down. This is how we imagine the future of a contract platform to look like. So yeah, the two key ideas that we're moving past the native rollup solution is the idea of a cloud, a computer that exposes an abundance of decentralized compute resources, and the hub, a specialized platform which allows it to be really easy to build and make applications onto this cloud, right? And depending on what kind of application you're building, you can access the cloud or you can access the hub. It depends on how much resources and how much tooling and how much ease of use you want to access. So yeah, the Polkadot ecosystem is thriving. It's growing a lot. We have over 600 teams across many different verticals beyond just DeFi. And it's really exciting. It's a really exciting space. All these people are coming along with us on this ride towards a Web3 cloud. And so yeah, I want to just leave you all with the ideas in the presentation that you are heading in the right direction with the native rollups, but I think there's more to be had. I hope that you will look at our technology, that you will join our community and build in our ecosystem. And yeah, really join the revolution. I mean, we're all here to build a better Web3 future. And yeah, thank you. If you want to say hi, I'll be at the booth for the rest of the day at booth 101. And yeah, if you want a link to this presentation, you can follow the QR code here, and you can see it for yourself. Thank you so much.
Okay, thank you so much, Sean.
Urging those dancing where the bottlenecks been. Professor Ways got the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not a compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age? Old to speak, young as each block mine down. Professor Ways got the future on spinball. Urging those dancing where the bottleneck's been. Professor Ways got the future on spinball. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just tried to do audible. He just tried to do audible. He just tried to do audible. He just tried to do. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And a hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stacking stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. CK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. Seated, the etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain.
chains.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do it do it do it do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. They cackle and shout, self-sustaining hubs flicker in the blackouts out. Professor Way's got the
Hi, welcome back. We have our next guest speaker here. Please introduce yourself and take it away.
Hi, everybody. Really excited to be here. I'm Sriram, founder at Eigen Labs, and the product we're building is called EigenLayer. What is EigenLayer about, and what are we really doing? So that's what I'm going to talk about today. When you think about EigenLayer, for many people, maybe some of you have heard of it. Maybe it's restaking, maybe it's DeFi, or maybe it's leverage, or whatever concepts that you may have heard around. I want to dispel all these myths and actually explain what we're doing. To do this, I want to start from, before we explain what we're doing, we need to explain what is the basis of crypto apps. So if you think about why build a crypto app, there are really few theses. One thesis is you use a crypto app for payments. Another one is that you use crypto. The first one is not a big market. It's like Stripe API. It's fine. It's not that big. The second one is you use crypto to decentralize your apps. What we've learned working on crypto in the last few years is nobody really cares about decentralization. So we have a new thesis for why we actually need apps built on crypto rails. We call this apps with commitments. What are apps with commitments? Think of an app like Bitcoin. What is the commitment that it is making? So the thesis says that an app is useful to be built as a crypto app if it's able to make commitments which are at high trust. As an example, Bitcoin makes a commitment that you own your coin. There's only 21 million coins. This is a really, really huge deal because no other system could make commensurate commitments. And if you look at any normie podcast on Bitcoin, this is what you hear. You don't hear about longest chain, all this other stuff. Same way, you can think about other apps that have found product market fit in crypto, like Uniswap. Uniswap's product, the main thing is you can find the fair market value of your asset. Or Aave, you can assure that a lender is worried when you're in a lending market. The lender is worried that the borrower can take your asset and run away. But Aave assures you that the borrowers are solvent. A Polymarket assures you that you're getting the real free market odds. And each of these applications, the thing you think about is if these commitments were made with high fidelity, with high trust, then the addressable market increases. And the lending market is a really interesting example because who will not lend if they know that they're not taking any material risk? So this is a thesis for why you should build crypto apps. But when you think about how to actually build these apps rely on a bunch of underlying services. Ethereum provides some of these services, but you need other services like Chainlink or UMA to actually fulfill these complex apps. So this leads us to the specific thesis that we're building for at EigenLayer. We call it the Verifiable Commitment Cloud. What is this idea? If apps making commitments is the really big deal of EigenLayer, the idea of a Verifiable Commitment Cloud is how do we give enough expressivity for apps to actually build with verifiable commitments? And so you see here at the very top, you see verifiable apps. Verifiable apps is what you want as the output. Now you ask, how do I build a verifiable app? And I think today, building a crypto app is very similar to how web application development worked in 1995. You have to either use a standard, simple framework, or if you want to build something powerful, you have to build your own server, you have to build your own payments, you have to build your own ID, you have to build your own database, you have to build your own services. But that's not how web development works today. You go and mix and match a bunch of underlying services, and you can actually use these services to build what you want. Like you use the cloud, like Amazon, you use like an authorization service like OAuth, payments with Stripe, and you can compose these services to build what you want. So what we have here is to power these verifiable apps, we need verifiable services. To power these verifiable services, you have a mechanism for making and keeping verifiable commitments, and that's what EigenLayer is. And to explain this a little bit, we can think about what is going on in the rest of the space. So you think about Bitcoin as the first OG application chain. And Bitcoin built an integrated blockchain towards a certain purpose, storing and sending Bitcoins. And so, if you think about the various layers of Bitcoin, a security layer, consensus layer, execution application, all of them built together and bundled. What Ethereum did is to unbundle applications, which means anybody could come and build applications on top of Ethereum. This ushered in the DApp, or the smart contract era, where you can go and build applications on top of Ethereum. But what you could not do is to change the execution language. You have to build everything in EVM. But you may not like EVM. You may want to build in Rust or Python or some other execution environment. And so that's the next step that we're seeing in the roll-up era of Ethereum. Roll-ups actually allow you to build an arbitrary execution environment and prove to Ethereum that you're actually done the execution correctly. And so that's what Ethereum 2 rollup era is. So allowing innovation not just at the application layer, but also at the execution virtual machine layer. What EigenLayer is doing is taking this to its natural end state. What is the natural end state? What is not possible today, even in the rollup era, is you cannot go and build your own consensus layers. For example, you want a group of n nodes to go and sequence your transactions for a rollup. You have to build it separately. It's not part of the Ethereum network. You have to build a new network. You want a bridge. You have to go build your own consensus network to actually consensus on the state of the bridge. Every new protocol needs its own consensus layer. This is an extremely hard bootstrapping problem for each one of these things. That's why we built EigenLayer. EigenLayer is pure shared security. There is a large pool of stakes sitting in a common place. Anybody can come and build new decentralized services and protocols on top of it. So when you think about it, we think about the marketplace structure. Many of you, like this verifiable commitment cloud is probably a new idea about EigenLayer. What you already know is staking. So look at the flywheel and look at the left side of the flywheel. You have stakers and operators. And stakers and operators come and start the flywheel. And once you have stakers and operators, you have AVSs that can actually build on top. Once you have AVSs, is the market complete? No, you have services. What is an AVS? An AVS is an autonomous, verifiable service, a service built on top of EigenLayer. It is autonomous because nobody can stop it from running. Anybody can stake and continue running that service. Number two, it's verifiable because if you don't do something correctly, you'll be held to account on EigenLayer. So AVSs are what all these services that build on top of EigenLayer. Now you have the staker operator connecting and providing security to AVSs. AVSs provide rewards to staker operators. But this doesn't finish the EigenLayer marketplace because AVSs need to be useful for some application that makes commitments to end users. So that's the whole picture of the flywheel. And we will show you where we are till now. So none of these just pure theoretical concepts. We made a lot of progress on every side of this marketplace, and there is a tremendous amount of momentum. So starting at the left, stakers and operators. So we started with onboarding stake first. Stake is any digital asset that you can lock inside the EigenLayer contracts. And initially, we started with restaking. You've staked your ETH in Ethereum. You can stake it also on top of EigenLayer. And our total value of shared security, stake available in EigenLayer, exceeds, this fluctuates on a daily basis, but it's probably around $13 billion plus today. So this is a huge pool of shared stake that can be utilized by any service that can come in and start using this to supply trust to their service. The next side we went to is operators. Do we have nodes which are capable of downloading and running all these services? What we find is, yes, we have nearly 2,000 operators in the EigenLayer ecosystem. This spanned the whole spectrum from home stakers and operators to Coinbase and Blockdaemon and professional crypto operators to non-crypto operators like Google Cloud running first-party operators on EigenLayer. This is the entire spectrum of node operators. You can come in, and when you build a service, you can ask for, I need a very powerful or very minimal operator set. AVS developers, this is the hardest side of the marketplace. each AVS is as hard as building a layer 1 protocol. It's extremely difficult. It's not like building a smart contract app, and we're also very early in the development lifecycle. We have 100 plus AVSs, many of them venture funded by the top venture capitalists in crypto. I think of AVSs as similar to software as a service in the cloud era. Software as a service ushered in a whole host of venture investment because each SaaS service is hyper-specialized, and it massively accelerated the rate at which applications could be built in the cloud era. That's exactly what we think AVSs are. This is a category map for AVSs that I had put up in December 2023. And as an aspirational category map, what kinds of things might people be able to build on top of EigenLayer? And this is what it was. It's about roll-up services like sequencer, bridges, MEV, keeper networks, bridges, AI inference, databases, all this stuff. Many, many, many categories. Every single one of them is being built today. From aspiration to actually seeing these being built is really, really crazy over the last several years. Okay, so when we think about this verifiable commitment cloud, as people started building these apps and services, we started getting information on what is possible and what is not possible. And what we started realizing is to build these AVSs and apps, you need certain core primitives. And primitives are things that pretty much every AVS needs. And therefore, we have already built a couple of primitives and will continue to build these primitives to enhance, accelerate the crypto app era. So the first one is identifying a problem with AVSs. When stakers and operators opt into an AVS and run some service, they are basically saying, if I don't run the service correctly, they will get slashed. To slash them, which means to take their funds away, you need to write an Ethereum smart contract. You need to be able to prove on Ethereum that they actually made some malicious action. This is a very, very complicated thing. As a reference point, OP Stack and Arbitrum took 5 years to write their optimism fraud proofs. So it's a really, really hard problem. It's not that they were slow. They're actually the best teams out there. It's because this is a really hard problem. So when you want to prove these frauds on chain, it can be very complex, very difficult. So what we've done is to create a new primitive for doing off-chain fraud proofs. I don't need to write on-chain fraud proofs. You can prove fraud by actually making claims off-chain. This is a really intricate technology. It uses our token in a certain new way. And so what this does is, giving another example of like things that you can never prove on-chain. Let's say an oracle said, Trump is not the president of the United States. How does Ethereum know whether this statement is correct or not? And we have new technologies to actually prove these things. The same technology also powers our data availability layer and can power a whole host of new AI services. So EigenDA is the other primitive. Anytime you build an AVS, you need a place to publish your data so that anybody can challenge and make it verifiable and slashable. And that's what EigenDA is. EigenDA's throughput today is 15 megabytes per second, which is 50x the Ethereum throughput, and many, many times 10x at least other data availability layers. We did a recent experiment where we crawled data from every chain, including Bitcoin, Ethereum, Solana, Celestia, everything, and you can publish all the data into EigenDA, and you have still more space remaining. So EigenDA is built to be hyperscale. So you can keep throwing more data on it, and you can actually get security. So there are other features of EigenDA I'll not talk about. And what we've done is take this idea of the verifiable commitment cloud and implement various levels of commitments, primitives, and services, and tools to enable all of them in our roadmap. Coming up next on our mainnet is slashing, which is right now on testnet and undergoing audits, a massive upgrade coming up for EigenDA, major partnerships including top brands like Layer 0, Enfura, ZK Sync, working closely with us on the application side, like Polymarket, working with us on these different features. Finally, I want to conclude with one thought. Crypto has an app problem. I laid out a thesis that applications with commitments is a new use case. On the other side, we see AI has a trust problem. How do you trust this AI? Crypto can supply trust to this AI. So I think this is a match made in heaven. And what we are seeing now is new and interesting AVSs being built to solve this problem, to endow AI with trust, to endow crypto with AI and agents as the new category of applications. And what we see is a whole new category of infrastructure services like data collection, generation, attribution, model training, fine-tuning, many, many new opportunities for developers to come in and contribute and build new and cool stuff on EigenLayer. With that, I thank you for your attention. If you want to find more information about us, please use these QR codes. Thank you so much for the organizers for this invitation.
Thank you so much. We really enjoyed that talk.
Protocols, how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Bugging tomorrow with yesterday's RAM stains. notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Age? Old speak, young as each block mine down. Professor Waze got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Throwing me mad, running me mad's just a beta test for Boodle. Oh, detox time. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stacking stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. CK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Sport marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's
Hi, welcome back. We have our next guest speaker, Uma.
Hello. My name is Uma. I'm the co-founder and CEO of Succinct, and today I'm going to be talking about how every rollup is going to be a ZK rollup. So I think something that gets talked about a lot in the Ethereum community is the notion of ZK rollups are the end game. And maybe a lot of people agree with that, but hopefully the point of this presentation is to convince you that not only are ZK rollups are the end game, but that they're actually here today, right now, with what we're building at Succinct. So today, most of the rollups that are deployed in production are optimistic rollups. Think rollups like Arbitrum, Base, Optimism mainnet. And the reason that is the case is that when those rollup teams were working a few years ago to deploy rollup technology, ZK was still hard. It was very difficult, it required a lot of cryptography, and so optimistic rollups were the fast go-to-market option. But optimistic rollups actually have a lot of hidden costs. The obvious one is the long time to finality, where you have to wait 7 days to withdraw your funds. And that's really bad because it locks up capital, it degrades user experience, and it makes interoperability between rollups really hard. Also, these optimistic rollups have very complicated contraptions for their interactive fault-proof game, which has this challenge period and interactive challenges that are economically incentivized. And in the end, the systems end up being very, very complex and actually hard to reason about. So as I was mentioning, why are most of the top rollups by TVL optimistic rollups today? That was because back a few years ago, launching a ZK rollup was really hard. Developers needed to implement cryptography and custom ZK circuits to make things like a ZK EVM. And proof generation was really, really expensive. So it would make the end user experience bad because transactions would cost a lot because you had to generate a proof for them. And finally, optimistic rollup teams went to market early. They had a hard time switching to ZK, even if those things were now different and ZK proving costs have gone down a lot because there's a lot of sunk cost in their existing stack. At Succinct, we're building a ZK VM called SP1, where you can just use ZK by writing normal Rust code. So SP1 is kind of a breakthrough in the ZK paradigm, where you no longer have to code custom circuits or do any complex cryptography. You can make a ZK EVM by just writing normal Rust code, like taking things like reth or revm, and getting them to in SP1 and getting out ZK proofs. So companies now can just make a ZK EVM by using SP1, and then they can use the Succinct prover network to generate proofs very cheaply and cost effectively.
Lower the mic just a little because it's covering your face.
Oh, cool.
Okay, there you go.
And finally, now that ZK is really easy and very cheap, existing rollup teams can just take their existing rollup stack, which is written in normal code, stick it in SP1, and get a fully working ZK rollup end-to-end. So we actually built this out for the OP stack. It's our integration called OP Succinct, and I'll go more into this later in my talk about how it actually works and kind of who's using it. So let's dive a little more into the performance of ZK VMs and how there's kind of this Moore's law where ZK is getting cheaper and cheaper and faster every year. We launched our ZK VM SP1 around 1 year ago, and back then we were able to prove around 60,000 cycles per second. And those are RISC-V cycles, which is the instruction set that we prove. Since then, over the past year, we've gone from being able to prove 60,000 instructions per second to 4.8 million to be exact, instructions per second. So that is a hugely dramatic increase in our throughput, which also translates to way cheaper proving and way faster proving. And we're also building this prover network, which is basically a hosted proving solution for SP1. So SP1 is a piece of open source software. You can use it, you can run it on your laptop and generate ZK proofs. But in practice, to make things cheap and fast, you need to run ZK proving on GPUs or other custom hardware to make it very efficient. And so our prover network is the solution where developers can send a program and an input via an API to request a proof. Provers and GPUs all across the world basically generate the proof and send it back to you and get paid. And it becomes this protocol where everyone can get ZK for as cheap and fast as possible. And that's what we're building. So with SP1 and the prover network, I like to say that we're in a new era of ZK, which I like to call ZK 2.0, where now anyone can use ZK in a much more modular way. In ZK 1.0, which was kind of the old way of doing ZK, where you had ZK rollup teams like Scroll and ZK Sync and Polygon, each of those teams would have to build all parts of the stack. So they would have to build their own rollup implementation, their own sequencer, node software, block explorer, etc. And then they would also have to build their own proof system, and they'd have to build a bunch of complex cryptography and circuits for a ZK EVM. And they'd also have to build their own prover and host all that infra themselves. In all, it was a huge lift, and that's why all these ZK rollup teams took a really long time to go to market and were many years behind the optimistic rollup teams. With ZK 2.0, what happens is now everyone can use SP1, our ZK VM. They just write normal code, and then they can use our prover network so that they don't have to have their own proving infra. So you can just tap into ZK but with the normal code, and then you can build whatever you want. You can build a ZK EVM, you can build a ZK SVM, you can build whatever VM you want, whatever state transition function you want. Really, whatever software you want to prove is finally provable. And this dramatically makes using ZK easier, the go-to-market timeline's way faster, and also expands the types of things that we can ZK prove. And so our hope is kind of in the ZK 2.0 era, ZK is finally easy, fast, cheap, and can get adopted everywhere in the stack, and will allow every rollup to be a ZK rollup. So hopefully I've convinced you at this point that, with SP1 or ZK VM and the prover network, ZK can finally live up to its potential. And now I'll talk a little more specifically about what we're doing to bring ZK to every rollup with OP Succinct, as I mentioned earlier. So OP Succinct takes the OP stack, which is a very popular rollup framework, and sticks it inside SP1 to get a full ZK rollup, which we call OP Succinct. And in particular, there's a lot of advantages. You have 1 hour fast finality. You can prove everything, and it's pretty fast and reliable with cheap costs. However, we also have another offering called OP Succinct Lite, which is perfect for rollups that are more cost sensitive. And this replaces the interactive fault-proof games that are used by a lot of current optimistic rollup teams and replaces it with a single-shot fault-proof, where instead of having this interactive back-and-forth dispute, in the case of a challenge, you can just verify a single ZK proof. And here, the kind of trade-off is that you get much cheaper costs because you aren't proving every single transaction. You're only proving something in the unhappy path where something goes wrong. But you still get slower finality than the full ZK option, so maybe around a day, because you have to still allow for time to generate the challenge proof and submit it. But you improve upon the 7-day finality that most optimistic systems have. So OP Succinct is kind of a good middle ground between full ZK and the interactive fault proofs. So in general, with OP Succinct Lite, I think one thing that's pretty interesting to note is that I believe it's a strict improvement beyond the interactive fault proofs we have today. Today's interactive fault proofs, like Optimus and Arbitrum are using in production, are very complex multi-round economic disputes. With a ZK fault proof, you can just resolve your dispute in a single step by verifying a proof. This means that not only are your finality windows shortened from 7 days to 1 day, it also means that your bond sizes that you have to put down for this economic game go from being hundreds of ETH to tens of ETH, which is much more efficient. And so you get lower bond sizes, faster finality, and just an overall much simpler code base, which is really awesome. So we think that ZK fraud proofs are future-proof and kind of the endgame direction of interactive fault-proof games. And then OP Succinct, which is kind of full ZK, where every transaction is ZK proving, gets you even better. You get really, really fast finality. So you can have finality in 1 hour, 1 day, maybe even tens of minutes. You get cheap, cost-effective proving, where the cost of proving per transaction ranges between 1/100th of a cent to 1/10th of a cent. So that's very, very affordable, especially compared to Ethereum DA costs. And then finally, because your state transition function's written in normal code, and our ZK VM lets you use ZK with normal code, if you want to add a new precompile or you want to customize your rollup, that's no big deal. You can just do that. You can write the code, stick an SP1, and everything will still work. So we think with both OP Succinct and OP Succinct Lite, every single OP stack rollup kind of has a path to this ZK future. So if you're a large L2 with strict security and interop needs, or a DeFi chain that has a lot of high-value transactions where you don't care about 1/10 of a cent here or 1/100th of a cent there, OP Succinct's a perfect solution. You can become a fully ZKified chain. If you're a more cost-sensitive L2 with thin margins, like a gaming chain or something where there isn't a lot of financialized activity, then OP Succinct Lite with ZK fault proofs is a great solution for you, and in our opinion, a strict improvement to the interactive fault-proof games that we have today. And I have an image here of an electrical engine, which is dramatically simplified compared to the complex gas engine that I kind of showed earlier. To me, the gas engine represents interactive fault proofs. They're complicated, they're clunky, there's a lot of steps going on, it's hard to reason about. OP Succinct Lite makes ZK fault proofs very streamlined and very friendly, and we think that's the future that all rollup teams should take. And I guess there is becoming more and more broad agreement on this ZK rollup future, where every rollup is going to be a ZK rollup. And Vitalik says he was even thinking about that in 2021. And the main concern is still proving costs. But especially with that ZK Moore's Law chart that I showed you earlier in this presentation, hopefully you're convinced that proving costs are an exponential trajectory to getting better and better. And actually, we even have a few OP Succinct chains running live today. And in practice, the cost per transaction is around 1/10 of a cent or 100th of a cent. So it's at the level of existing L2s already. And so I think the time is now for chains to start adopting either full ZK or at the very least ZK fault proofs to kind of go towards this future that we see for Ethereum rollups. And kind of as evidence of what I was saying of people already using this technology, we actually have a bunch of customers for both offerings that are using this today. So we recently announced that we're working with Mantle, which is a ZK, which is an L2 with a lot of TVL, around 2 billion in TVL, one of the largest L2s, and they want to convert their chain to be fully ZK with OP Succinct. And we have another chain called Fala that does TE AI agent experiments on their chain that's using OP Succinct in production right now. In addition to that, we have a bunch of other customers that are going to use OP Succinct Lite in the upcoming months as they think ZK fault proofs are a strict improvement on the security they have today. And there's a ton of infrastructure partners across RAS and Alt-DA that are also supporting both OP Succinct and OP Succinct Lite. So in sum, hopefully this presentation convinces you not only that a ZK is the end game, which is a common phrase heard throughout the ecosystem, but also that ZK is here right now. It's easy, it's cheap, it's fast with OP Succinct, and people are adopting it today, and we should be moving towards that future to have a better, more interoperable Ethereum. Thank you.
Thank you so much. It was a pleasure to listen to hear you speak. So.
Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch they rock on P Island. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spinball. Urgent notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plug in tomorrow with yesterday's RAM stains. blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin, energy nodes dancing where the bottlenecks been. Professor Wade's got the future on spin, bugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Who's your nemesis? Like runs dial-up found. Old as speak, young as each block mine down. Professor Wade's got the future on spin, energy nodes dancing where the bottleneck's been. Professor Wade's got the future on spin, bugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jobs, She's a
Hi, welcome back. Today we have Rob Green with Patchwork. Please take it away.
All right, thank you very much. So, well, and the remote that I have is not working. So, all right, we're going to go like this. Hi, everyone, I'm Rob. This image that you see here was generated by Claude 3.5 Sonnet, I believe. 3.7 was not out when I made these slides 2 weeks ago, but I think a lot of the things are going to apply almost exactly the same. I asked Claude to generate a cartoon-like image of a bald man with a black shirt smiling and waving like that. And I think really it did a pretty good job. It made an SVG, but can you see anything that's wrong with the picture? Yeah, one hand, right? Now, this does a pretty good job sort of summarizing what you get out of naive LLM usage. It's close, but there's something a little bit wrong. So LLMs are not always great at designing perfectly cohesive solutions, meaning that it'll accomplish a few tasks, but when you look at the whole end-to-end, it might, some of the parts from the beginning might not actually match up with the end. It can't always think through the consequences of a design, meaning that it'll give you working code, but sometimes there's some really hidden troubles in it. And one particular problem is that sometimes even in a single file, it will generate code that uses different versions of the same library, so that code couldn't possibly compile and run the way it is. And it also doesn't always fully understand your intentions. Now, LLMs are actually very good at talking to you in your natural language because they're trained in your natural language. They're pretty good at just making up stuff. Like they're making up some data, making up a function you might need. They're great at mimicking examples. So if I say, hey, here's an example of a thing, can you now apply a different style to it and do the same thing? It's pretty good at that. And they're excellent at copying things they've been trained on. And that's really key. I think most people know all this by now, anyone who's been using them. So when trying to use an LLM to write a smart contract specifically, rather than list the exact problems, I'd rather show you an experience I had going into it as a naive developer with my prompt. So I wrote this exact prompt. I said, write me a smart contract that is a game item system. Make weapons with modifiers where the modifiers can be purchased and assigned to the weapon. Make armor sets where the armor pieces, again, are purchasable individually and then get assigned to the armor set, but these can be unassigned and traded separately again. I got a little wordy, but I figured that's how people talk to them, right? And so it says, yeah, great, I'll make you a smart contract system. And so what I'm expecting to see is something like this. I mean, I think I said I want to be able to buy the modifiers separately, right? So we would think they should maybe be 721s that I could maybe buy on OpenSea, and I want to be able to assign them to the weapon. And same with the armor. I want to be able to buy pieces and put them on an armor set. So I think this is reasonable expectation of what my prompt would have described. But it didn't do that at all. And I'm not going to show all the code it generated because it generated a couple hundred lines to try to create this, and it made it very bespoke and non-standard. And I said, no. Make it so that everything is a 721 and that there are different contracts for each type of thing. Because it tried to make one mono contract that had all the things and had a purchase function that something would know how to call and all types of stuff, even though I explained that. And it said, okay, I'll split it up. Good, we're getting somewhere. And then I got a contract from that, and I noticed that when I had an armor set, that it didn't consider what happens if I sell the armor set. It didn't consider that those armor pieces maybe should also belong to the set. That means when I sell the set, it should belong to the new owner. And I said, all right, I want an armor set that when sold applies the new ownership to all the assigned pieces of armor, right? And it goes, okay, I'll cascade the ownership, right? And it did. It wrote that. Now we started trying to compile, because this is just me getting the code back and looking at it. And I noticed that I was trying to compile it with OpenZeppelin 5 and the latest, which has been out for a while, and some of the code didn't work, and it said, oh, you're right. I used OpenZeppelin v4. I'll update it for v5. And I said, okay, it gave me code. I tried to compile, it still failed. So I pasted the errors in. It said, right, yeah. In OpenZeppelin v5, things changed, so I'll update that for you. And I was like, okay, good. Finally, we're going to get past this. So it gave me new code. I pasted it in. I'm like, what? Can you just fix this, please? And it goes, sorry, I guess in Open Zeppelin v5, something changed again. And I'm like, we talked about this, right? I thought we were using v5. You can't get this. Okay, let's go. More problems. And it goes, I see. The issue is that I'm still not using Open Zeppelin v5. This is really my interaction with I kept taking the code, try to build it again, same thing. This just continues. Here, again, it's like, oh, okay, well, now in Open Zeppelin v5, something changed. It's now virtual, I gotta change it. I'm like, okay, well, let's keep going. Still can't compile the code it gave me, and it said, okay, we're getting somewhere. We just need to make sure that we have the right imports, that we have we're now using the hooks. And finally, it generated code that compiled except for the test, and I looked at the test code it generated, and it literally concatenated an old version of the test it generated and a new one, if you can see it. So I just hand copied that off and said, okay, we're not perfect here. And after 28 iterations with 3.5, I finally had working code, right? So we're all good. Right, it was a little bit more work. It would have been nice if that had been an agent. You would have just watched it loop 28 times and do the thing instead of me telling it. But at least we have some code, right? So we're good. Well, the problem is that once I got the code from it, I looked through it, and I realized that what it generated for me is largely unusable. It never asked me how I want the mints to work on these 721s. It just sort of made an assumption and ran with it. And what I wanted, and what I sort of would expect a system to be able to do, is to offer some form of self-service, meaning a user can show up and they could go to mint.fun and create something, or maybe they could maybe we just have something where there's some payable mint function or something, and they can buy the item they want. But it sort of assumed that I was just going to mint all the items myself and put them for sale myself. And that was, an assumption that I didn't want self-service. One huge problem is that it had zero logic to check. Again, it generated working contracts. It generated working tests. Everything passed. But it had double assignment errors, where if I had that armor, like I was talking about, there's an armor set. If I assign those pieces to one armor set, I could mint another armor set and assign the same pieces to it, and then the cascading ownership would break when I transfer the second one. So it was really a broken contract. There was no data-driven setup for the mint strategy, so I couldn't say I want it so that this is a helmet and it costs 0.000333 ETH or something. I couldn't do it, and a ton of minor issues. But after all those 28 iterations, I still have to start over. I have to make new contracts because these aren't going to work for me. The biggest issue is that the LLM itself does not understand the greater architecture required to build safe, efficient, and interoperable contracts. And some of this is pretty specific to smart contracts, because there's a lot of great examples out there, but you have to get awfully specific if you want it to actually work in the way I was just saying. Like if I want there to be data that gets pushed to it to configure minting, and I want users to self-service. So a person running into these problems might assume that, well, the LLM just didn't have enough context, right? The logical next step is, let's refine the LLM usage. Let's tell it the logic in detail that we want to have. Let's give it examples. Let's give it more context, and let's refine the core prompt. Surely I can prompt my way out of this. Okay? That's logical. Now, if you do that, the good news is that you're going to significantly improve your output. It does work better to refine your prompts. But the bad news is that it's still just grabbing and generating contract code out of nowhere. You still have to manually audit every single line. Not just audit, you have to think through logical minds that are going to be in there, like that double assignment problem. A lot of people wouldn't notice that, and I'm sure it had other problems I didn't notice as well. And you're only going to find out after you deploy this code, right? And it's questionable if this is better, that whole process is really better than just manual development for one-off contracts that you're going to make. It might be safer to just do it yourself. So you saw the prompt that I had in the first place, right? I posted that. This is my refined prompt. I'm not going to read it to you. but you can see it is full of technical details. I'm explaining exactly which function I need to have. I'm telling it what modifiers to put on it. I'm telling it data types to use for things. I'm giving it rules. I'm saying only use OpenZeppelin v5. I'm saying make sure that you can only assign a weapon modifier to one weapon at a time. I'm saying make sure that only the contract owner can actually add weapon configurations. I'm giving it everything, and I'm giving it an example contract. This is what I mean by refining your prompt. You literally have to go this far in order to one-shot something, or even get a few shots of response to get something that is what you want. And you have to think through this ahead of time. So it's kind of a pain, right? So I'm going to propose today that people consider a hybrid approach. All right, I'm going to call this the 80-20 approach. I'm going to say that you should either use an existing library or existing software, or develop, if it's really custom, develop procedural code generation that does about 80% of what you need done. Let's say you're an app and you're going to need 40 different smart contracts. It's an asset system or something, and you've got all these classes of assets. I think that you're better off generating 80% of the code for those, and then only customizing the little bits that are really different, unique, or different logic with each contract, either by hand or with an LLM to do that, right? And if you do this, the LLM's requirements go down substantially. It no longer has to account for your overall design. You're doing it. You can give it really detailed context on what it needs to have. You can give it the exact logic that you need, and you can give it an example, and your prompt will be smaller, and it will do a much, much better job for you, because it doesn't have to do all of it at once. It can just focus on the custom logic that you need. This approach is applicable for projects that have lots of contracts, or where lots of different but sort of similar contracts, or groupings, classes of contracts. Right? Now, if you want to develop code generation tools, the general process is, first, you need, either manually or using an LLM, you need the correct code. So it's just fine. I mean, prompt away, get the code that you need, audit it, make sure this is right. Then templatize it. Take that code that it made, refactor it a bit, make it so that you have just those reusable sections within a template, and then now you can just generate the contracts, and it's always that audited code you're getting every time, right? Add some tests, and you're guaranteed it's deterministic, and you're going to have success. So you might say, no, that's not what I'm interested in. I think that we just need LLMs to get better and better at doing this. They will, right? This sounds like a very old school approach, because it is. But the reason that it's not a bad approach is because it's highly effective. The output you get is deterministic, and not doing this, the alternative is typically I made a couple of contracts, and I copy and pasted those to these others, and I changed the logic, and I copy and pasted those. We've done that at our company, and I can tell you that we almost always forget something or another, and we have funny little bugs here and there, sometimes not severe, but copy and paste is only so good. The bad news is it's upfront. The upfront cost is pretty high, and if you're trying to make one or two contracts, this probably isn't the best approach for you. Right? So if you're interested in this, you could say, well, what things are really good to generate procedurally? Things that are going to be conventions across a group of contracts. Let's say you're going to have many contracts that are mintable. Well, the mint functions that you might want to have, the relations that are going to be, so if my contract is going to relate to this other contract, generating the code that enforces the relationship is great. Anything involving the mint strategy, so I can upload the same way to tons of different contracts I have. Just anything you see repeated across contracts is a good candidate for procedural. So if you're wondering, well, how do I go there, though? How do I actually do that? Well, this is a project configuration that we use. What we're doing here is, if you can kind of read this code, this is just some JSON that is showing, it's not JSON, this is TypeScript, and it's showing that I have some contracts, I have a character, I have a game item, they have these, here's a model, I've got these fields they need to have, this one, we have a thing called fragments, it relates to this game item here, so my generator can look at this and it can say, I know there's a relationship between game item and character, I will generate the code to securely manage that relationship for you, I know that you want these fields of these types, I will generate code that can handle the bits of security that you want for access to those things. Right? So the way a workflow works like this is first, you need to make that app configuration, something like I just showed. Then you pipe it through a procedural contract generator. I could speak. There are actually many out there that you can use. You will get some generated contracts, but those generated contracts are going to be missing some of your custom logic. So you take that generated contract, you give it a refined prompt, you put the two together through the LLM, and now you have a final contract where you only need to audit the diff between the generated contracts and the LLM generated parts. It's significantly easier to do, and you get far more security and much higher chance of success with your code gen. So an example post-generation LLM prompt, like I showed you my one before, paragraph, lots and lots of logic rules in it. This is an actual one you could do. I could say, now that I have a generated contract, I could say, modify the contract given to add the following functionality. A weapon modifier increases durability or damage of the weapon it is attached to. So it'll add some code when you assign that weapon modifier, it'll modify the weapon. And then I want to say only one of each weapon modifier type may be attached to a weapon at a time. And here's my generated contract. Your LLM now has a very high chance of success. It can see where it needs to go. It can see how everything's already laid out. It doesn't have to do any guesswork. And it can probably generate this code just fine, and you can probably audit it just fine. So we have a full implementation of tools that do code generation. We're not the only ones that do that. But if you want to take a look at any of this stuff, we have a system called Patchwork that takes that configuration and does all of that. If you're curious or have questions, please join our Discord, and we'll help you out with anything that you're trying to do. I'll leave this up here for just 1 second in case anyone's interested. Also, I'll provide a link at the end too. And the future of code gen, ultimately, we all know we're heading toward no code. We know that in the future, it's going to be plain English that you're going to use to write your software. Things like smart contracts may stay special case for quite a while because of the general permanence and because of how big a blast area is when you have a bug and how sometimes you just can't fix it. It's on chain. You're done. But we know we're going toward no code, and I think the real question, though, for us engineers is, what does that look like under the hood? We know the user experience, but under the hood, is it just a sea of agents, or is there a bunch of hybrid stuff under there where we're making specialized frameworks for agents to use as tools to give us secure generated code? And I think it might be something like that. There's a link to the slide, some resources, and whatever you need. And I'm a little bit early, but that's all I've got. So thank you very much.
No, thank you. Appreciate your conversation out here. So, well done.
For we bid led the city on sports and
She's a Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked intrudes from trash sheets. That's my device. Nullifier sniffing by my cokes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch me be rock on PI. Get homemade in 7/4 time. Shaboom dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Urgent notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Bubbles flutter like drunk bumblebees. Optimize the orphans. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Age? Old as speak, young as each block mine down. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Buddha. Oh, he just tried to do audible. He just tried to do audible. He just tried to do audible. He just tried to do. We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. Another bubble, watch it crash. But we don't need your central banks. 'Cause regen biddlers stack in stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks, backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do it do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my cokes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Blood eyes everywhere, not just 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Ran it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it
guitar slide. Wah, wah, guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7/4 time. Shaboom, those efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, boy. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. bugs flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin, Air-G nodes dancing where the bottlenecks been. Professor Wade's got the future on spin, Bugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial-up found. Age? Old as speak, young as each block mine down. Professor Wade's got the future on spin, Air-G nodes dancing where the bottlenecks been. Professor Wade's got the future on spin, Bugging tomorrow with yesterday's RAM stains. Calling me mad, but mad's just a beta test. A bullet on heat on sky. Heat on sky. Heat on sky. Heat on sky. We're biddlers, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. No rug pulls, just pure on chain. If you fade She's a Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernet whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomping blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with as firewall splinter to confetti bits, I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. To get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, urging notes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging those dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial-up-found. Age, old to speak, young as each block mine down. Professor Way's got the future on spin. Urging those dancing where the bottleneck's been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jobs got to do. 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 We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stacking stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we biddy let the city on sports and chains. We biddy let the city with regen brains. We biddy let the city on sports and chains. No rug pulls, just pure on chain.
Hi, welcome back to our very last performance. Today, I have the pleasure of introducing Patrick from Arweave with our last presentation. So please take it away.
Let's see. Hey everyone, my name is Patrick Skinner, and I am a senior developer relations engineer for the Arweave ecosystem. I work for PDS, who runs the RIO as well as the R drive tech behind Arweave. And today I'm going to be talking about something called METT-TC for DevRels, which basically is a Army Ranger or Special Operations methodology for preparation for basically any type of mission possible. It could be combat missions or even like humanitarian missions. And I've taken this principle and I have basically implemented it specifically for DevRels. And it seems kind of like a stretch, but as you go through and you learn a little bit about METT-TC, you'll actually see why it applies so well. My favorite quote in the world is always, if you find yourself in a fair fight, you didn't plan accordingly. And that's something that's always been near and dear to my heart, because every single time I've ever planned for anything, I've never felt like there's ever been any type of like over planning. You've never told yourself that you over planned for something, and because you over planned, something went wrong. That almost never happens. It's best to over plan and always have success than to under plan and risk the probability of having some sort of failure either during the event or for the entire event itself. So a little bit about my background. I'm a former Army Ranger medic, a paratrooper medic, and I was a mass casualty coordinator. I've got several deployments. I was actually the mass casualty coordinator for the earthquake in Haiti. So, I mean, it's interesting how much planning goes into not just the combat side of things in the military, but also the humanitarian side of things. And I'll tell you that in the military, we spend, especially in the Rangers, we spend so much time planning for something that could only take maybe 20 or 30 minutes. You know, a single mission, depending on the situation, could be a couple hours, could be 20 or 30 minutes, could be a couple days. It just depends on what the mission is. And I came into the Web3 space and started working as a DevRel, and it really astonished me how much there was a lack of planning for online events, lack of planning for IRL events, lack of planning for execution of pretty much anything, either by the engineering team or by the developer relations team or by the marketing team. It was astonishing to me. And so I really decided to go back into my principles and started saying, okay, I feel like I want to spend much more time planning and have the perfect execution, so that way I'm not always chasing my tail. The team itself isn't losing resources or constantly chasing their tails on what went wrong on the last event or on the last execution of any mission that they had. So something you're going to learn is, like, in the Army Rangers, we have this book called the U.S. Army Ranger Handbook, and it's 200 plus pages of just mission planning, basically. It's astonishing how much planning goes into missions. So when we plan for anything, we would plan, and not only just plan, but we would do tons of research. We get as much intel as we can. We do all kinds of reconnaissance, and we would take days, maybe weeks, even months of planning. Even if the mission was only supposed to be executed in a 20-minute or 30-minute window, it would take months and months of data and planning. And I feel like we need to spend more time doing that inside of the tech space, because so much resources are lost because of poor planning. And so what I've done is I've taken this principle, which is called METT-TC. METT-TC, for the Army Rangers, it means mission, enemy, terrain and weather, troops and support available, time available, and civilian considerations. Now, when you turn that into DevRel, make a couple changes. Still stands for METT-TC, but it's ecosystem, understanding your target market. Troops and support still stay the same. I like to call my teams troops. And then at the last two, the time available and cost considerations. Because at the end of the day, cost considerations is still a casualty if you have very poor planning. That's the biggest casualty in Web3 is a lot of cost considerations. I understand that there are millions, actually obviously billions of dollars in the Web3 space, and yet I feel like we spend way too much time thinking we have all this money, so we have room for mistakes. But in the reality of the situation, we need to take in consideration that cost in itself is very much of a casualty because of poor planning. Okay, so mission. Understanding the mission is ridiculously important. So I have this quote up here. I love military quotes. I live and breathe by them all the time. But this one's by General Mattis, very famous Marine Corps general. He says, the more clearly we understand what we're trying to accomplish, the greater effect we can have in accomplishing it. People need to understand the purpose behind what they're being asked to do. It is so important to make sure everybody is so mission driven. If we lose sight of the mission, then execution, not only just execution on the overall mission, but execution on the smallest average tasks just become lacking on an average basis by, it could be something as simple as a PR by an engineer. It could be something as simple as a single tweet by a marketing person. The moment they start losing sight or maybe not even understanding the greater goal of or the greater mission, that's when things start lacking. And every single little mistake inside every single little task, whether it's a PR, whether it's a post or anything like that, whether it is an update to the documentation or the SDK, those little mistakes add up very, very quickly into basically creating a critical failure overall. So it's very, very important to understand the who, the what, the why, the when, and the where when it comes to missions for the overall team. And this is also very important. This is a great question to have too when you start hiring people or you start talking to people inside of the ecosystem you work for. If the people you're hiring or the people that are building inside of your ecosystem, if they themselves don't understand the mission, then maybe you don't live by the mission yourself that enough, because the people that you are basically supposed to be, perpetuating that mission to don't see it coming from you. So it's very important to make sure that that mission is overly stated, not only to yourself, but to your team and the people building inside of your ecosystem. All right, so the ecosystem. It is perplexing at the very least to say that so many DevRels, when I ask them general questions about their ecosystem, so many don't have any of this done. Market research, SWOT analysis, they don't have competitor intel. At the end of the day, competitor intel is interesting because all of us DevRels, there's this running joke that DevRels probably have more loyalty to other DevRels than they do the company they work for, which is so true. But at the end of the day, it is still important to understand what is the competitor technology like? What are they doing that's making them successful? But it's also good to also understand what are they doing that's maybe causing them to fail. It's important to understand those kind of things and try to act as best as you can to make sure that you're taking advantage of the information that you have, advantage of the intel that you're receiving. Also understanding the overall tech stack. I work in the Arweave ecosystem, so that means I haven't touched Solidity in a while, and I probably should. And I haven't done it in a little while, but it's important to understand what tech stack are you working with? So then that also means what tech stack are you expecting people to build with in your ecosystem? That also means who am I targeting? Who am I trying to reach out to? So if I'm in the Arweave ecosystem, should I be constantly pushing information to people that have no care about decentralized front ends or decentralized data storage, and all they want to do is build, I don't know, AI, or they want to build just with Solidity, that's probably not my target market all the time. But there may be overlaps where I do want to target those. So it's important to understand the tech stack and make sure that you are constantly communicating not just to the ether of Web3 and hoping that that information lands to the right people, but you're actually really directly talking to the people that you intend to have building your ecosystem. And then regulatory landscape. There's a lot of times where a lot of people are trying to talk to people that honestly are vastly restricted, or maybe they don't even have the means to be able to build inside of your ecosystem. So instead of just, like I said, shouting in the ether, we want to make sure that we're talking to people that are either trying to maybe solve these problems with your technology or are unrestricted by the regulatory the landscape that is existing in specific parts of the world. So again, down to target market, you want to understand the demographics, the psychographics, and then behavioral patterns of the engineers or of the people that you are trying to have build inside of your ecosystem. This is really, really important because I think this really is linear to, let's say, the mission. Because you can find, let's say, engineers that are building with the tech stack that is linear to your technology, but maybe the demographics, psychographics, and behavioral patterns aren't matching with your mission. Maybe they're not interested in building with that type of technology because that's just not what drives them. So you want to make sure you truly understand what drives the people that are building, the people that are building actively in your ecosystem. And then obviously engagement channels. We all know that Web3 in general is very, very busy inside of X and channels like that. So I'm not going to sit there and push all of my content and all of my information or anything like that and spend a lot of time on Facebook, because Facebook isn't going to really drive a lot of traffic for me. I'm not finding a lot of active engineers in that space. So understanding the channels in which I can best engage with those people. Obviously, I'm leaving out things like Farcaster and such, but Farcaster is a great place for that. And then community leaders. Community leaders inside your ecosystem, but also community leaders that could be linear to your ecosystem. Those are great people to communicate to, because the moment you communicate to them and you've won them over and they start communicating to their community, that's a great way to also grow your ecosystem overall. So troops and support. With internal teams, I actually just got done having this conversation with a couple people, and one of the things that's really interesting is DevRels. There's not a single DevRel that is like another DevRel, and there's not a single DevRel role that is exactly like another DevRel role. For myself, I like to say that DevRels are a bit of a sliding scale of, like, you have the technical content creator, and then it slides all the way to the opposite side of a little bit more of like the introverted side, and that would be like a solutions engineer. And you have to understand that if you're building a DevRel team, that DevRel team needs to be able to complement each other. If I have a bunch of content creators, but nobody is really good at the solutions engineering side of things, then your team is very off balance. You need to make sure you have a very balanced team. Great quote by General Phil Schuyler, and this is: the strength of the team is each individual member, and the strength of each member is the team. So you want to make sure everybody's skill set as a DevRel is actively complement each other, and it's not polarizing. They're not trying to do the exact same thing. They're all executing on the same mission, but in different ways. So that also covers team skills, tools and platforms. So the support side is like, what tools are available to you? And this is also going to go into cost considerations and everything as well. If I can have tools that are 10xing my efforts on a regular basis, then yeah, absolutely, that should be part of the tools that you're actively using. But it's important to make sure you're doing consistent research and finding tools and things that are going to be able to help you execute exponentially on a regular basis. So, this could be anything from like Claude or Cursor or any of those tools like that. I'm able to build starter kits ridiculously fast with Cursor, and then I just review the code, make sure it's sound, and make sure that it's all tailored to the engineers that I'm targeting. And I can get that done probably 5 or 6 times faster using something like Cursor than I am able to do it, pretty much on my own and hard coding it. External partners. This is where the DevRel love really happens, and this is why DevRels love to meet up at DevRel brunches and so on. Because DevRels, we love to communicate to each other and see how we can collaborate. How can our ecosystems work together? How can we pull basically developers from each other's ecosystems and kind of almost like create a singular ecosystem. This is really, really important to make sure that you're constantly developing new external partners to support each other. And that's where, as much as like we like to say, it's important to understand competitor intel or have competitor intel, it's also important to have external partners to find synergies between other protocols or maybe even competing protocols, depending on where there could be synergy. And then resource gaps. Always, always, always try to identify where the gaps are, because those gaps are the ones that on missions we call those blind spots. Because without having proper intel, if you don't have information on something, then that's a gap. And you're not going to know it until that gap is exposed, and then that weakness becomes something that is honestly fatal in a mission. In our case, it could be very, very cost heavy. Having something like, good examples, like there's the Arweave booth right now was not properly tested before the event. So because of that, they're having tons of electrical issues and everything like that. So it's important to check those gaps and make sure that you have the ability to prevent things that could be very costly, either costly with financially or costly by time. Time available, which, by the way, I've got 3 minutes left. The time available is also very important to understand. You need to understand project timelines. You need to understand what the event alignment is. You want to understand how much you need to have done before a specific event so that execution of the event itself is smooth. Resource planning, market windows, buffer zones, these are all very, very, very important to understand very early on. And then cost considerations. This is the casualty of poor planning. If we don't understand fixed costs, so things that we know are going to cost a specific amount, and we need to understand the variable costs and how can we benefit from variable costs, and how do we not get hit by variable costs when they're the most expensive? This could be a variable cost. A good example of this is waiting till the last minute to buy tickets to ETH Denver. Making sure your team is very forward thinking, realizing, okay, who physically needs to be there, who doesn't need to be there. Let's get these tickets in December. Let's not get these tickets, a week before the event. Let's try to be very proactive in that kind of stuff. ROI, understanding the return on investment when it comes to sending either 15 people or 5 people, depending on what's going to be the biggest benefit. And the contingency funds and the funding strategies, we're talking like burn down charts and everything. How much does the DevRel program cost me, so that I understand what am I going in with on the mission, so that as I'm starting to execute, I don't overspend or underspend. And then in implementation, this is just basically having this plan, being able to execute on this plan repeatedly, because the terrain always changes. That's something that's very, very important. When it comes to mission planning, the terrain will always change, but the process of planning will always stay consistent. So as long as you're managing and staying consistent with planning, no matter how the terrain changes, whether it's at ETH Denver or whether you're at Singapore, you always want to make sure that you're constantly executing in the same way each and every single time, so that it becomes like a muscle. Planning is always something that you want to execute on repeatedly. All right, so that's pretty much it. But if you actually want to see a very, very detailed article on METT-TC and how to execute with METT-TC, this is a QR code that you can use. It's a very long article, but by all means, I highly recommend going through it because I do have quite a few resources in the article as well. And I'll give it just 1 second. Okay, cool. So on this one, this QR code, this is actually a PDF document that you can download and you can use to go through the METT-TC planning for anything that you want to do. If you want to go through METT-TC for your entire DevRel strategy, this is a PDF that you can fill out and be able to try to do all of your pre-planning for either ETH Denver, or it could be for the entire DevRel program of yours. So it's something that you can repeat on either small tasks or very, very large tasks. And that's it. If you don't, please follow me on X. I appreciate you guys being here.
Thank you so much, Patrick.
I ended with 3 seconds left.
Yeah, we did it. Nice. If there are any questions, please let us know. We can definitely bring you forward and have some comments in that. But if not, we'll call it at that. This is the last presentation of the day, so let's all go home and eat because we're all hungry. So,
thanks for being here.
Centralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Sta-do-do-do, boo-boo-doo-doo-doo, boo-doo-doo-doo-doo, do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do-do. Alliance architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do, with a do-do, with a do-do, with do, with do-do-do, 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 with a do-do, with a do-do, ho-ho-ho. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I scoop and truce from trash sheets. That's my device. Nullifier sniffing on my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, flurry, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 burner phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it.
Guitar slide. guitars.
Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch they rock on P Island. Get homemade in 7/4 time. Shaboom goes the efficiency pulse. The lad runs lagging in his latency sub. Professor Way's got the future on spin, boy. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out.